Hi, Julian. Can you hear me?
I can hear you.
Yeah.
Sorry, I was a few minutes late.
Yeah, not a problem. Participants are also slowly joining in.
Fantastic, fantastic.
Yeah, so how are things out there?
They're good. They're good. It's actually a holiday today in Hong Kong. It's our 1st of July handover celebration.
Oh,
it was sunny. Now the sun's gone in, which is good. Otherwise, I'll be blinded.
Yeah.
How are things in Kerala?
Yeah, things are going good. So our lockdown has been lifted. Still minor restrictions, but going good. Yeah, going good. Yeah.
For COVID, we've been very lucky. We haven't had a proper case for a couple of weeks now.
Oh, okay.
But then we can't go anywhere either. So
yeah, we're all locked in. Yeah.
A mixed blessing. Sorry, my phone went off.
So Julian, shall we start?
Right. I was on mute.
That's okay.
I said, yeah, I'm happy to start whenever you're happy to start.
Yeah, so let me start with a formal welcome.
Okay.
So good morning, everyone. We are really excited to have Julian Gordon, who is the Vice President of Hyperledger Asia Pacific and Linux Foundation Public Health. So a little about him. He has spent the past 20 years in Asia Pacific business development and leadership roles within leading technology companies like HP, Sun Microsystems, Juniper Networks, and Cisco. He is a strong advocate for open source and the transformative potential of blockchain. So he is a community builder for the Linux Foundation to bring people in and, to be honest, really motivated Saintgits to contribute to the Hyperledger ecosystem. So we are really privileged to welcome the head of Asia Pacific for Linux Foundation, Julian Gordon, for his keynote on the most sought after topic from CBDCs to supply chain to vaccine credentials. So over to Julian.
All right. Thank you, Anina, and thank you, Jacob, and thank you, Saintgits, for this great opportunity to present here today. I've been watching a bit of a sessions. This is a great inaugural open source conference, so I'm very excited to be part of that. So what I'm going to do is I'm now going to start with my presentation, right? And I'll get that up and running. So today I've been asked, and I think I have about 30 to 40 minutes plus Q&A. So if you guys have any questions, anyone has any questions, please do ask in the chat. I'm happy to take questions. I know it's a reasonable audience, but it's good to, you know, for intimacy, happy to take any questions as we're going along. So today I've been asked to talk about how open source blockchain is changing the world. And obviously that's the theme of this event today, is all around open source. And I'm going to be looking at that through the lens as well of what we at Hyperledger, our technology has been used for, from CBDs to supply chain to vaccine credentials. So what I'm going to do today, I'll firstly actually go back and talk a little bit about what Hyperledger is, right? Because I know it's predominantly a technology audience. We'll look at the technology as well. Then I will look at the use cases, and then I'm going to look at how you or anybody, everyone is welcome to get involved in Hyperledger. So what is Hyperledger? Well, Hyperledger is the blockchain project or initiative within the Linux Foundation. We were founded 5 years ago, and it's a place where anyone can come who's a developer, who's interested in blockchain. It's a neutral place that people can come together to develop code, develop solutions, discuss, and help the acceleration of this technology and to all the benefits, societal and business benefits that will provide. So it's basically a very welcoming community. We have grown rapidly. We started, as I said, 5 years ago in 2016. Actually, our first code which was Fabric, was in March of 2016, and since then, as you can see, we have now over 15 different code bases. We have many of those production releases. We have a global community. A lot of this is done in India. A lot of this is done in Asia Pacific. For me, it's China, India, and the rest of Asia Pacific. We're seeing amazing momentum, amazing development, both sides in terms of development and in terms of the implementation of these technologies. So let me have a little bit a look at those technologies. So in Hyperledger, we have what we call a greenhouse. This is where our technology is developed. It is a neutral place for people and safe place for people to develop code. We have developed, as I said, 15 different code bases. This is all done under the guidance of our technical steering committee, and you're going to be hearing later from one of our technical steering board members, from Arun, but they overlook the development of all these different projects. And I'm going to go into these a little bit. And within these, within this umbrella, within this greenhouse, and the reason we call it a greenhouse, these projects all work together. They're all under the same governance framework. They're all under the same IP framework in terms of licenses, and they're all under the same governance. So a very, very, very symbiotic environment exists within our greenhouse. So I'm going to just quickly go through the different distributed ledgers we have first. We have Fabric, which I think is, I think everyone, if you're in blockchain, and I'm not sure of the level of the audience in terms of understanding it, but Fabric is probably the number one open source enterprise blockchain. So number one blockchain, contributed originally by IBM and digital assets, and has grown and grown and grown. And I'm going to talk a little bit about that. We have other equally successful projects such as Sawtooth, as you can see here on the right. We have Sawtooth, which is another permission. Permission has some interesting and maybe a simpler, and maybe some people say easier to implement format. And actually, a lot of that was developed. It was originally contributed by Intel. A lot of that was actually developed in India by the Intel team in Bangalore. We then have a project called Eroa. So Eroa came out of Japan, more focus on applications or mobile applications. And I'm going to talk about a great case study we have there with one of the first ever CBDCs in the National Bank of Cambodia, which is using Eroa. And then we have Indy, and actually we put Aries together with that, and maybe Ursa. That is around self-sovereign identity. Now, self-sovereign identity is the ability for you to share your identity like you would in the physical world, in a privacy fashion. So when you share identity from the verifier, when you share your identity on the internet, generally people have to go back to the original source to check that it's true. This self-sovereign identity enables you to share identity without doing that. So you can look at your credentials and it doesn't have to go back to the original issuer of those credentials. So that has some very significant implications and opportunities. And actually a lot of stuff we're doing today around vaccine credentials is using this technology. And then we have the other part of the blockchain world, which is around Ethereum. So we have a couple of Ethereum projects, Burrow, which is an EVM, which is a smart contract engine within Ethereum. We've had that for a number of years, and that's integrated in Fabric and in Sawtooth. So within Fabric and Sawtooth, you can use EVM or Solidity contracts. And then finally, Besu. So Besu came about 2 years ago. That is a Java-based Ethereum client that enables us now within the community to use some of our code to work with Ethereum, to actually even connect into the mainnet of Ethereum. It can be used for a public, and it can be also used for Ethereum, enterprise Ethereum permissioned blockchain. So those are all our distributed ledgers. You can all see those. They're all available. We are truly open source, and we have many, many technology companies working with us and universities and others developing and using these technologies. I'm not really going to go into the libraries. We have a few libraries here. Please do look on our wiki. We have a bunch of tools. Some of these are quite interesting. One of very interest and quite a hot subject is around interoperability. That is a project called Cactus that was contributed by Fujitsu and Accenture, and that has provided the ability, and it's still in incubation phase, but it's the ability of one chain to work with another chain. So two blockchains can work together, and it's all about how those business processes work together. This has always been a hot issue, and originally it was a hot issue, but really it didn't have an application because we're all developing our first chains. But now as the world becomes more complicated with multiple different chains and multiple different forms of doing that, communication between chains, interoperability is becoming a hot subject. Avalon is all about working with off-chain and in speeding up the chains, and a lot of that is using enclaves or anywhere that you can go off-chain, do the processing off-chain, come back without losing the trust that exists in a blockchain. And then we have a bunch of things in our Hyperledger labs. So if you're technical, please go and have a look at these projects. And I'm going to talk a little about how you can get involved. We have the Indian chapter. There's many ways that you can learn more about these technologies and learn from the community. If you're someone implementing it and you need to implement that in a real world situation, how can you learn about other people's best practices? Or how can you, if it's a new area, how can you set up a kind of open source environment to learn about what other people are doing and maybe lead something like that? So that's our greenhouse. Just a few more points to that. Hyperledger Fabric, which I said is the most popular, is on every single major cloud. So it's easily accessible. You don't just have to go for the raw code. Every single cloud provider pretty well has Hyperledger Fabric. They generally have other things as well, maybe an Ethereum client as well. But the one consistent is Hyperledger Fabric across all, including, I can see in China, all the large cloud providers in China also using Hyperledger Fabric. So it's very hard, and when we talk about how Fabric is doing relative to other flavors within blockchain, there's no kind of IDC report. So we always use this Forbes as a kind of indicator of the success of blockchain technology. So Forbes, which you probably all know, is a famous business magazine from the US, and they do surveys. And this survey is, they call it the Blockchain 50. They survey and get responses from companies over $1 billion who are using blockchain technology. They then select 50 of those as the top 50. And if you look at this slide, what this slide tells you is that in 2021, 60% of the Blockchain 50, 60% of those companies were using Hyperledger technologies. In 2020, it was 50%, and actually in 2019, it was about 50% as well. So we're seeing a growth in the number of companies using Hyperledger technologies as a percentage. And you can see most of it's Hyperledger Fabric, but we do have a range of other technologies using there. I'm just going to point out a few here, which will be interested. We have two of the largest banks in the world, ICBC and China Construction Bank. They're two of the largest banks in China and also the largest banks in the world in terms of assets. And they have been working And I've been using Hyperledger technology, I think, for the last nearly 4 years, since the very beginning. And I've had very large, predominantly trade finance networks looking at things like letters of credit, how companies, suppliers, and buyers work together, and simplifying the process. And in that case, removing some of the requirements of some of the messaging systems that existed before, making the financial system more efficient. China Construction Bank, for instance, they have what they call a forfeiting system, which is a form of trade finance. They have done over $50 billion worth of transactions over that network. I pick out other companies, famous companies like Carrefour, Walmart, who are all involved in food trust, providing provenance to make sure that the food that you see in your supermarket come from where it says it comes from. And actually, vice versa, to make sure also if there is a challenge with the quality of a product, or let's say an outbreak of salmonella, maybe in some green vegetable, they can know where everything comes. They understand the provenance of where everything comes from in their supply chain. We have Nickel in the mining industry. We have Maersk, who are part of TradeLens, which is now has the ability to track its community of shippers, provide about 50 access to 50% of the world's containers, and they're tracking containers from port to port globally, and providing accessibility and greater efficiency in that, but also ability for people to do trade finance by tracking containers around the world. And Tech Mahindra in India is the first Indian company to enter, and I think there'll be many more. So there's a lot of stuff happening, and definitely was underrepresented. Tech Mahindra, I think, probably the most famous case study is around spam. So they're working in India. I know in India we have lots of spam calls, so they're working a system between all the different telco providers to help provide ability for telco companies to track who is spamming calls. So help everyone, our citizens, so you don't have to spend your life having spam calls and spam texts. So that's just a fair share, just an indicator. And these are really, I think, is the very tip of the ice of the mountain of solutions and out there. And these are some of the biggest companies. BHP, another one there, that's around trade finance as well. So that is just a little bit of the technology. So now let's look at real world case studies. That's what I was asked to do today, and I think everyone wants to know, and I can talk a lot about open source technology, what we've done here, why the technology is useful, why everyone can access to it. But technology is no use, whatever you develop, as long as it's used for some kind of business and societal outcome. So I'm going to take a few data points here first before I go into these use cases. This is from the PwC, who have done a report on the global impact, economic impact around the world of blockchain. And they're tracking, is what they said, even despite that we've had this terrible pandemic. In many ways, the pandemic has accelerated digitization. So it's taken down some of the economic activity, but it's increased the need for, as we don't, physical paperwork, and people meeting physically is part of many processes together today. But digitization obviously improves that, and blockchain enables that. So it looking at up to 1.76 trillion added global economic impact by 2030 by blockchain. So that's a very large number, right? And interestingly, they say that most businesses will be using blockchain technology by 2025. So this is a great report. You can read it. I've got the link here. It shows India here at 62 billion. And as one of the leading countries that will get a lot of benefit from this, but also China, actually 400 billion. China has been very, very much from the beginning, very much focused on this technology. France, Germany, Japan, Sweden, every country in the world is working on blockchain and how it can help create, with that universal truth that it creates for all the parties, how that can help create greater efficiency, new business models, and more effective ways of business being done, and helping society as a whole. Another area that people talk to me about, said, wow, we're doing lots of POCs, which is great, because we all understand that this technology that is going to have a great impact, but we're not always sure exactly how that's going to be done for our industry, for let's say in our government department or in our educational establishment. So there's been a lot of proof of concepts, especially for large companies working out what it's going to be doing in my supply chain, how that's, should I have a digital currency of some sort, these kind of things. And as with any technology, it's good to test it first and work out the unintended consequences and the benefits of it. But what we're seeing in 2019, this is from a survey, so these are the survey respondents, it's not 23% of companies, it's 23% of people who responded to, this is a Deloitte study. 23% said that we're now moving into production. In 2020, they saw, even despite what happened in 2020 with the beginning of the pandemic, it surely is going up to 39%. And I see that, in my, I don't have the statistics obviously from my view, but as I see, I have a great view of what's happening in blockchain, and I've seen a lot of things move into production. And actually, we even have stuff in multiple years of production for blockchain networks. And a lot of the challenges of moving to blockchain technology and using technology isn't always the technology, right? It's the legal network that has to be set up, the governance of how you govern a network, managing different organizations together. It can be a challenge, and it's something that you have to go through. But once you get that, the benefits, outweigh the challenges that existed. And on the right, this is just saying that it's just really giving an indicator that a lot of the production actually is with large organizations. So of that 39% respondents who said that they are seeing things go into production, most of those 46% work for companies over $1 billion. So now let's get to the crux of the matter, right? So I know that everyone wants to understand what kind of use cases they are. So what I've done is I've taken that $1.76 trillion that PwC had shown, and now we're going to split it into what they say were the three areas of growth. So first was payments and financial instruments. So they're saying there's going to be 433 billion potential boost to the global GDP with blockchain for payments and financial instruments. And that is predominantly around restructuring the plumbing of the global financial system. I have been working since, I think, the beginning of my career. I worked in banks and I worked in banking technology, and there's a continual replumbing of how the technology can be done. A lot of the challenge is a lack of trust between financial institutions, not because they, they may be regulated, but how can they trust each other when they are sharing transactions? And obviously blockchain can do that. There have been an opportunity for brand new instruments, and I'm going to be looking specifically a little bit at CBDCs. That's a sub-area that I think there is a lot of interest. And also, there's kind of three worlds. There's a CBDC world, which is a central bank digital currency managed by a central bank and regulated. There is this thing called a stable coin, which means many things to many people, but that's kind of like the Libra kind of world where things, where it's not regulated by like a central bank. So there's no recourse if something goes wrong, but it represents some other underlying asset and maybe a fiat as well. And then there's the whole cryptocurrency world, right, which is a completely different world. So there's kind of three different kind of worlds, and how those are going to work together and which ones, and what the prognosis for all those is what I think everybody is working out. And central banks, as it says here, 86% of central banks are looking at their area and how those other areas affect the whole economy and the financial infrastructure of the countries and interbanking and between countries. And it says 80% of central banks are exploring CBDCs and 60% have pilots. So if you look on the right, we have a number of examples, and I'm going to go into two of those in a little bit more detail. So we have the Bank of Cambodia's project for Bangkok, which is around a retail CBDC. So I'm going to look at that in a minute. We have the Eastern Caribbean Central Bank. That is Eastern Caribbean covers, I think, about 6 different countries, which are islands, and they were one of the first true CBDC to go live, and they were on Hyperledger Fabric. We have the Bank of Thailand project. There's a bunch of different projects around this thing called Indian Lion Rock, and a lot of that's looking at the wholesale CBDC. But I'm going to talk a little bit about that in the future. Another infrastructure is around equities. So how are stocks traded? There's a lot of inefficiencies when you trade and buy and sell stocks. You do a lot of settlement. You have to work out who the buyer is, the seller is. You have to make sure that you've all agreed the price. There has to be a reconciliation, and when things are reconciled, you then do payments. So a lot of delay. So when you buy a stock, there is generally a delay for the bank that is dealing with, or institution that's dealing with the exchange. So Tel Aviv Stock Exchange is working, and a lot of our stock exchanges, Singapore Stock Exchange, stock exchanges around the world are working about how they can create efficiency. There's a famous case in the Sydney Stock Exchange as well, who are looking at their clearinghouse system. So a lot of work there. And this is just an example. Tel Aviv, who are working with one of our members, BTP, and they're using actually Sawtooth to build a blockchain securities lending platform, which enables peer-to-peer lending and supports a wide range of contracts. And once you create efficiencies within this trading environment, you can create greater liquidity, because it's easier for people to trade. Things can happen faster, and that adds to the kind of whole trading and kind of game theory. And the third one is around bonds, and I'm going to be looking at that in a little bit more detail. So those are three areas: CBDCs, stock exchange, and equities around financial instruments. So I'm going to first look at a central bank digital currency. So I'm going to take these quotes. I think I took these from BIS, which is the Bank of International Settlements. So what is a CBDC? Well, a CBDC is a digital currency issued by a national bank with a legal tender status. So by a central bank, like the Reserve Bank in India, the Reserve Bank of Australia, the Feds in the US. So it's issued by the national bank. And similar to a fiat currency, a CDC will be controlled by the central bank in order to regulate fluctuations and maintain stability to the financial system. So what's the difference between cash today and a digital money you work on today? Well, today's digital money, so we all work on digital. I use a credit card. I have a thing called Octopus. I do all kinds of things. I go online, I buy stuff, but that's all account based. Even if you're using a credit card, when you pay it, ultimately your credit card is paid through an account based, through the account at your bank. So it's account based versus what we're looking at here is a token based currency. That cash, like cash. So physical cash, I give you cash. No one knows that I gave you the cash. There is no account. I don't have to move an account anywhere else. It's physical cash. So this is a token based. In an account based monetary system, the accounts are under bank control and payers must prove their identity to access the funds credited to them. However, in this token based CBD system, the payer must only prove that they own the currency units. And that may be just proving that they're holding a private key to access their wallets. So the reality is, in a CBDC, I can have money in my wallet. I go up to you and I can give you the money. And you take that money from my wallet through whatever process, and that's done through private keys, through cryptography, and then you have the money. So it's very simple. There's no processing. It has to go back to my bank and leave my bank account. It's like real money in the digital world. So why is that useful? Well, it creates great efficiencies. We don't have to encumber the whole system. It has to be secure and private. It's better than cash. It has a wide, it can be, we're seeing wide spread adoption, and it has consistent regulation. So you can make sure that you can control. One of the things about other currencies and other digital assets is that you don't have any recourse. So if you make a payment, an error in a payment, you can always get recourse. And also it's useful for cross-border payments. So those are the benefits. CBDCs, what are we working on today? So most banks, as I said, are evaluating a CBDC. Libra and what is now called DM, I think was a catalyst, and DCEP, which is a digital currency of China. They are one of the catalysts, I think, that have accelerated. So I think there's a whole acceleration. People understand that this needs to be done, and it's acceleration obviously has to be done with the checks and balances of managing your currency in a central bank. But we're seeing a lot of pilots. The US dollar, euro have talked about it and they're kind of an exploration phase. I'm going to talk about the Bakong, which is one of the first ones. And when we have a bunch of pilots, in the HKMA, Bank of Thailand, Central Bank, UAE, in Australia. So we're seeing, and I mentioned the Eastern Caribbean Central Bank. So lots and lots of stuff. And actually, we announced this week, or MAS announced this week, a competition which anyone's likely can enter, which is looking for people to submit and enter a kind of hackathon type system to help accelerate this, to look at all the problems, because there are a number of still challenges to CBDCs. I would say it's still in its nascent phase. We're still doing a lot of pilots, but it's very much happening today, and it could change how a lot of things are done, how you can manage your money. And I'm going to point particularly, actually, I think an area that it particularly is of value is in places like Cambodia. So Cambodia has about 50% of the 50% unbanked. I saw Sireya Shea, who is Her Excellency Sireya Shea, who is the National Bank of Cambodia's director, and she was saying that in many people don't have banking. And actually, you have what we call people have personal ATMs. Other people look after your money for you, right? But with this, people can manage their own money. So they launched a new private permission blockchain system back in 2009 called Bakong. It's the first retail payment system in the world using blockchain. And it's really what they call a quasi CBDC. So there is still some control in the backbone of the payment system. Its goals was to reach the unbanked, especially in rural areas where people need this. They don't have to rely on third parties to manage their money. They don't have access to banks. And also in Cambodia, people use US dollars and others. So people want to have more use of their national currency as a means of payment. It reduced liquidity and compliance burdens on the service providers, and it's just a complete modernization of the system. Places like Cambodia can leapfrog all the infrastructure that exists today. So the result, they've got 16 banks supported. It's a retail throughput of 2,000 transactions per second, and it also not just helps the individuals who are trading it, but for the banks, they can see their daily position. So it has a daily batches, which used to happen twice daily for banks switching where money's being used, up to 5 seconds. So this is we have a case study. We can look at this. This is, I think, one of the great case studies on CBDCs. Yeah, lots of quotes. I'm not going to go through those today, but we're seeing a lot of excitement in the central bank digital currency phase. Another area that I mentioned was the bond market. So the bonds, why bonds? So why blockchain for bonds? Why are we looking at blockchain for the benefit of the bond market? Well, first, it's the size. Bond market is actually one of the largest investment categories out there in terms of assets. It's bigger than equities. And in fact, in many ways, it could be considered, maybe safer than equities, because in many ways, right? But there's a debate there, right? But yes, size is definitely an area, but really it has many pain points. It is very many times illiquid, and it does not have a transparency that people need to feel, super confident to be able to get the right price. So a lot of that is the fact a lot happens over phone calls today. As you can see, the economists say it's shockingly archaic. Price data is hard to come by. So as an individual investor, we don't get that access. So the market, people in the market can see that. It has large minimum size, $200,000. I mean, who has $200,000? That is a limited number of people who can do that kind of accessibility. So it's not accessible to the millions. And it's predominantly non-exchange traded, and therefore largely liquid. So with all those problems and that size of the market, this is an opportunity to use blockchain to create the efficiencies to be able to bring down the ticket size of bonds and create a market where people can get accessibility through, just like you can buy your equities just through a phone, right? And they wanted to replicate that for the bond market. And this is Bond eValue. They are a Singapore company, but I know a lot of the work is done in India and Hyderabad. And they came up with the vision of where more investors can trade bonds on the go without the restrictive minimum investments. So they called this thing called Bond Blocks, was the exchange, and it's been implemented by a fully via a fully regulated bond exchange based on blockchain. And by the way, it's sawtooth with fractionalization. So you can take your bond and they will cut the bond up into bits. So you can just buy a bit of a bond. It's regulated by the MAS. It went into the MAS sandbox, and it has custodians, those who safeguard the cash and look after the assets. So there's third parties that you can trust that are managing the assets and the cash in the exchange. And this has gone live. It went through the sandbox, went through all that rigorous regulation, and it's come out today, and it's live today. So what's the technical solution like, and what are the benefits of this bond exchange? Well, first, the solution is leveraging Hyperledger Sawtooth combined with a scalable AWS serverless stack. It's non-forking BFT consensus for settlement finality. So that was a key point of why they're working, I believe, with Sawtooth. It's a multi-mode permission network with the exchange and their custodian partners who are in the same blockchain, so they can put that trust, and it crosses multiple cloud providers, not just AWS and on-prem. So it's in multiple different providers and different nodes. So it's actually a very complicated solution, but it's gone through the regulator. It's gone through all those checks and balances, and it's gone live. So what are the benefits? Well, you now can electronically get to your bonds, and you can buy bonds. The settlement is instant, because the thing about settlement systems, why you settle, so let's say I buy something from you over the phone, later on we'd have to do paperwork check. Here we don't, because we know immediately when money moves against a stock, it's done instantly. Everyone has a copy, it's trusted. So you can do instant settlement. And also the prices are transparent. It's liquidity. It has a greater liquidity because of the way the bonds are curated and the way we have the fungibility. You can see the bonds. It has accessible, so small ticket sizes. Used to be $200,000, now just $1,000, right? And by the way, you don't go directly to the exchange. You would normally go through a third party, such as a broker. It's B2B2C, so it scales with partners. So that's the exchange. First B would be a third party intermediary, like a brokerage or your bank, and then ultimately the consumer or the investor. And it's regulated, and it has a third party custodian. So this is the first of its type. I see this as an incredibly successful solution. It ticks so many boxes. It solves so many problems in the bond market, and it could very well revolutionize the way the bond market works. Okay, so that is the whole financial services. We looked at payments, we looked at CBDCs, we looked at the stock exchanges, and we looked at the bond market. There are actually many other areas in the financial services industry. Financial services is one of the largest IT spends in the world, right? And we see a lot of efficiencies and new instruments being created through the benefit of having this trusted network that a blockchain can provide. The second area, and in fact, actually, it says it's more money here. That's what the it's creating a potential boost of nearly $1 trillion by 2030. And this is all about verifying and tracking of goods that go down the supply chain. So, is this phone a real Apple phone? Is the battery in it really come from an area that is where it's ethically mined? These are the things that people want to know, and can now be tracked through a blockchain, creating that single point of truth. And prevent fraud, customer loyalty. It touches all industries. So I'm just going to quickly go through this, just checking here for time. We have we.trade, which is a large trade finance consortium, which is, and we have lots of those globally. Walmart, as I mentioned before, Walmart were one of the, and we're going to hear somebody from Walmart later, talking more on in terms of Hyperledger. They were one of the early instigators. They were one of the first, and they're in the blockchain 50, I think, because of their vision. And they're looking at how they can look at the supply chain, make it more efficient, and also make sure that they can have visibility to any problems and challenges in the supply chain. And we see that from provenance, that I can trust that this Fuji apple comes from Fuji, and as well as making sure that they have efficiencies in their supply chain. And then we're going to look at the final one. I'm going to go a little bit more detail on FDA compliant Brune chain, which is developed with UCA and Biogen, and that is tracking pharmaceuticals to the last mile of the supply chain. So this is obviously something I think should all be close to all our hearts, is the pharmaceutical supply chain. I saw a stat the other day that said up to 2 billion prescriptions are written in the US every year, and that was in 2019, and 100,000 of those are written are inaccurate. Actually, I had 2 of my brothers are doctors, and knowing how people write, I can see how errors can happen, right? I think we all know that, right? The way it has paperwork, manual transcription from one system to the other, and it's just prone to error. So the challenge for us in the 21st century, and this is something driven very much by the US government as well, is to reduce the errors and also stop an illegitimate product. So we know when we get a drug, when we know we get a Pfizer or whatever the drug that we get for our vaccine, that we know it's true. So we have the Act. So they regulated it. So the US, they came out with the Drug Supply Chain Act, Security Act of I've forgotten the actual date, but I think it's by 2025, pharmaceutical companies have to comply with this act to make it more secure. So this is talking about here, Ledger Domain and UCLA are talking about a case that they did in the US with around a pharmaceutical, a drug that is called Spinraza, and that helps babies with spinal muscular atrophy. So what happens to the drugs? They normally come from us. You can track them to the pharmacy within the hospital, but then they normally get split up and they get distributed in many different ways. They end up in a fridge. They end up here. They didn't really track them, and these drugs, remarkably, and this is quite a fact, the Spinraza, they cost $125,000 US per drug. So it's a very expensive drug. And obviously, if it's not used in the right way, it's not created at the right temperature, and it gets lost, that is not good. So they put together this thing called Broom Chain, which tracks through a barcode, through a phone, through a blockchain, a network which connected all the parties. They scanned the drug as it went from the pharmacy all the way down to the actual, the provision of that to the patient. And it was very, very successful. They were tracking so many things, right? They say the scanning functionality was 100% effective. They were able to track every dose of the Spinraza, no lossage, no leakage, down to which refrigerator each dose was stored in across the campus. This has been so successful, they're now looking to expand this with more nodes, more pharmaceutical and biotech enterprises, and thousands of dispensers. And if you think about it, it's even bigger than that, right? So how, and there are many examples I can say, we have at our forum, we had Z-Lig, for instance, who are looking at tracking of vaccines. How do you track things from where the produce that comes into our pharmaceutical, all the way, some of it goes across many different supply chains, ultimately to a hospital or to a dispensary, and then to the actual patient? How do you track that? Highly complicated, but highly important and highly efficiency. If you can get that in place, you can create great efficiencies. You can reduce the cost and leakage, and obviously we can create greater trust for us as patients. I'm not going to cover this very quickly because I think maybe I'm not sure on time. So Trust Your Supplier is a blockchain network that enables people to replicate onboarding. At the moment when you onboard, and by the way, this is Chainyard. This is a North Carolina company, but a lot of this work is done in Corella. They have a team there, and they're working on onboarding of suppliers. At the moment, if you're a company, you want to onboard a supplier, especially a large company, you have to go through a lot of paperwork. Make sure you have their business certificate, make sure that they are insured, make sure that they are financially suitable, right? So you have to go through all these things. So every time you take on a new supplier, there's a bunch of paperwork that happens between procurement and the company. And once you're on board, that's great. But then if I'm selling, let's say I'm selling tractors and I have to do it another time, right? I then have to go through all the whole process again. But another company's already done it. So what they're saying here is that once you onboard by one supplier, you should take that and the fact that you have been trusted by a very large company, that trust should be able to be taken to another company that you want to onboard. And those are amongst the buyers. So the buyers, once one buyer trusts and has proven that a supplier is trustworthy, then you should be able to take that trusted information and everyone should be able to use it. And to do that, you need a blockchain. And that's what they've done here at Trust Your Supplier. I'm not going to go into much detail. There's a lot of good work here and a lot of breakthrough work in terms of decentralized governance. They have a strong governance board, as you can see there. There are many buyer members validated. It's a complex business network, but this has been a very, very successful. For instance, like Ariba, and you have to do many different things in terms of the provenance of checking your you may go to a third party to check your creditworthiness. They are attached into the system as well. So it's pulling that whole buyer and supplier together. And this proved very valuable when we had, supplier onboarding. Okay, takes 2, 3, 4, 5 months. Maybe that's not a problem. But when we had PPE, when we all wanted to buy PPE and we wanted to bring on suppliers when we have an emergency, this becomes a bottleneck in providing a swift solution to a problem. When we need PPE, we need to onboard people quickly. What do we have to say? If somebody's already taken that PPE, that company provided that PPE before, we can just take their data, we can trust it. I'm not going to go through that in detail. We have many solutions. This is around supply chain. One of the key areas that I see has been very successful is where supply chain hits finance. This is around data warehousing. So I have assets. I'm a company. Let's say I've got my animal sitting in a warehouse. I want to be able to use that. I mean, it's money sitting in a warehouse that I can't use, right? So I want to be able to use that as collateral to a loan. How do I have a receipt to prove that that exists? Well, blockchain is the way. So providing the trust, they have cameras, IoT devices, checking where your goods are. And then people who are providing the collateral, people like banks say, actually, yes, I do trust. And I'm in that network. I trust that that is your aluminium and where it exists. So now I can give you a loan against that. So another great case study. This is another case study. I love this about provenance. This is in China, where they have internet port system. This is about provenance of your goods, of your paperwork. So you put your claim up to the legal chain. It goes to the court. It goes to the prosecutor and all the other people. But how do you know when you actually come to court that that is the paperwork that originally you submitted? Well, you put everything, hash all your documents, put them to the blockchain, and then later on you can just check that they're yours. They have over 70 million documents in this chain, and it's alive today. Been live for about 2-3 years there in China. Identity. Actually, Jacob, how much longer have I got left?
Yeah, Julian, we've got 5 more minutes.
Okay.
8 minutes, including Q&A.
Okay. All right. So the last area is around identity. Identity is a big subject. We're talking about this. The one I was going to talk predominantly here is around Hyperledger Aries and Travel Pass, the ability to make sure that you can trust when you go from airport, when you leave Kerala and you go and land in a plane, land on an airport in Germany. How do they know that your vaccine credential is true? And this is done through self-sovereign identity. So I'm not going to go through this in any detail. Another case, this is around self-sovereign identity being used in Sierra Leone for their country Kiva, for their country credit identity system, using self-sovereign identity again. So we would like you. So all that great solutions, and we have far more than that, right? That we can share with you. We want you to get involved. How can you get involved in this community? How can you add? How can you get involved in these kind of solutions? Learn more about these solutions, and maybe help other people learn more about this stuff within this non-profit open source community that we are today. Well, you're going to hear a little bit from the Indian chapter today. In India, we're very lucky. We have an Indian chapter with some very gifted people running it and a very vibrant community. So please join it. You can scan this QR code and you can get access to that. We also have special interest groups around any industry you're interested. Just come along and get involved. You can see the stuff. We can send you all this information. If you're more technically minded, we have stuff around technology as well. And also, we do training, free training, all available. And you also can, if you wish, go through our certification process. And if you become a certified, you can then actually help companies become certified service providers. Okay, that's just a quick overview, right? I think I went through all the areas, CBDCs, vaccine credentials, and supply chain and much more. Really, this blockchain is changing the way the world works, and we would love you to be very much involved in that. And thank you for your time today, and I'm happy to take any questions.
Yeah, thank you, Julian. So do we have any questions from the participants? Feel free to unmute yourself. You can also drop your questions in the chat box. Yeah, Julian, we've got a question. Yeah, for reopening economies, many countries have started deploying a health pass. How can we ensure interoperability and privacy leading to a better adoption?
So yeah, so that's self-sovereign identity. So we have many solutions. We have a whole project called the around the Linux Foundation Public Health. The way to do that is create a is work with self-sovereign identity. So you provide the ability to issue a certificate, and then you check that against the blockchain. It goes into your wallet, and then when somebody is accessing that credential, they can check against the blockchain to make sure it is true and it is creditworthy. Not creditworthy, but it is a true a vaccine credential. So we're working on a number of different projects globally. We have actually code sources around this area. I know in India there's a project called DivOp, which is COVID spelled backwards, very clever. There's a number of different projects working on this globally. But self-sovereign identity is key to that. And then that's just within your country, right? Then another issue we're looking at is a global registry. And we have a thing called the Global COVID Network. And they are looking at how we can create a registry between countries. Europe is very advanced in this at the moment, between how you can work between your vaccines between different European countries. So if you go from Belgium to Italy, or Italy to Germany, how do you know when your Italian certificate, you go to Germany, they know that that's proof. They go through the QR code, they then check it up through the registry across countries. We're now looking at how we can do that globally. So if you're going from Germany to India to Brazil, how do you know that when the immigration officer sees your certificate, that they know that that's true? So that's all around self-sovereign identity. And that's where blockchain is enabling this trust network around the world.
Yeah, Julian, we've got a question in the chat. Sheila Rani is asking how it will be used in education sector. So Sheila, can you be specific, like
yeah, Sheila. So I think the number one area is your certificate, is your degree, right? So how do I know that? And the self-sovereign identity, again, it's another certificate, right, that you get given. How do I know that that Sheila has a degree from wherever she has a degree, right? At the moment, you normally have to ring up Saintgits, find out there must be a process, right? But the way that we're looking at, lots of countries are looking at this, is that you could issue it on a blockchain. And that makes it far easier for employers and others who need to check your certificates and your CV, that those are real. That's one area anyway. Any other area, Sheila? Sorry, I jumped in.
Yeah, we've got another question. Will CBDCs disintermediate commercial banks? How CBDCs can address accelerated bank runs and privacy?
So the first one, sorry, was, sorry, I didn't catch those.
Yeah. Will CBDCs disintermediate commercial banks? That was the first question. How CBDC can address accelerated bank runs and privacy?
So first, I don't think it will disintermediate banks, right? I mean, banks have to be more efficient and more effective, right? But really at the wholesale bank, so there's three types of CBDCs actually, just to make a bit more clarity, right? We have a retail CBDC, we have wholesale CBDC, and then we have what's called multi-CBDCs. So at the retail side, it's generally going to be issued ultimately through the commercial banks. That's how most are doing it, rather than directly from the central bank. So the commercial banks will be involved in that area. So I don't think they would be necessarily disintermediated, but who knows? That's a very interesting question. You know, we don't know what the future will hold, but I think it is going to be inclusive of those banks. In terms of wholesale CBDC, that is interbank. So at the moment, banks, which many of you are not aware, they're always borrowing, lending money between each other. They're trading bonds. They're trading, trading cash between each other all the time, right? And some of that actually already happens in batches, right? We have retail gross settlements, all kinds of things. But what they're looking at is how that can create great efficiency by using a token-based rather than an account-based system, which they're using. And actually, there's a very interesting project called there's Partia, which came out of Project Uben in Singapore, where they are looking at that, which is between JP Morgan, DBS, and Tamasak is an example of one they're doing that. And then there's the MCBDC, where many many countries are working together. This is about currency exchange, and that was what HKMA have done. A Bank of Thailand have done, the Central Bank of UAE have worked on a pilot in that case. So how you can run the rails between what they call the payment rails. So at the moment, it's a challenge. If you are an individual and I want to send money from, let's say, Karela, let's say you're working abroad and you want to send money from Germany to Karela, it costs a lot of money. So how can we bring that down? Actually, if you look at the Sipnindu, who's the CTO at the Chief Finance Officer at MAS, he was talking about how can we keep that down to $1. And actually, this is this big challenge going on at the moment, CBDC challenge, which the Singapore government or MAS has just announced, which we're part of as well, about how we can look at that, how we can create that efficiency, enable that. I think banking the unbanked, creating it more efficient for people who have to pay large fees for sending money around the world is something that is going to be pretty important and pretty effective, and hopefully will help a lot of people. So the other one was the bank run, did you say? Or are you talking about the rails? The other question, sorry.
So do we have any other questions? No. So I think there are no more questions. So thank you so much, Julian, for joining us today. And thank you so much for giving us all the support that we needed to get going. So we look forward to contributing to Hyperledger more. So do you want to add anything?
Yeah, and thank you, Saintgits. I didn't mention Saintgits is translated to Malayalam. Saintgits is very much part of our community, very much a leader in some of the activities he's doing. So I personally want to thank Saintgits as well for all the work that you're doing. We are a community. We all work together. So I really do thank you for that and the great work you're doing with these great events. And I'm very happy to help contribute, talk to anybody out there, so we can take this technology forward. Thank you.
Yeah, sure. Thank you so much. And we look forward to contribute to Hyperledger. Thank you.
Okay. Take care.
Take care.
Thank you, everybody.
Yeah. So now we'll be having a hands-on session on Hyperledger Fabric by Krishna Suri Narayanam. So Krishna Suri Narayanam, can you start sharing, and can you please test whether sharing is okay or not? Can you please test that?
Hello, hi, I'm Krishna. Can you hear me?
Yes, we can.
Okay, sure. So let me start sharing the content that I have. Can you see my full screen?
Yes, perfect.
Okay.
So before starting, let us start with a formal welcome and over to Dr. Jubilant.
Video.
Hello.
Yeah. Yes, Mr. Krishna Suri Narayan. He is a senior research software engineer and a master inventor at IBM Research India Labs, IRL, Bangalore. He is a member of the Supply Chain Research Group at IRL. He was working as software engineer at Symantec, Pune, before joining IRL in 2010. He has 15 years of experience in developing and delivering distributed computing solutions. He is an inventor of 30 granted US patents and author of IEEE SCO peer-reviewed research papers and a senior IEEE member. He obtained an MS degree in computer science and engineering from IIT Madras in 2006. And his areas of research include blockchain technologies, cloud computing, data duplication, virtual storage utilization, business analytics, data security and privacy, IoT, and quantity solutions. Okay, I welcome Mr. Narayan to the program. Okay, welcome.
Yeah.
The floor is up to you.
Yeah, thanks a lot, Chakab, Professor Chakab. And yeah, good morning, everybody. This is, I'm going to talk about an introduction to blockchain. So I want to structure my talk in the following way. I will first talk about a general introduction about blockchain, and then I will talk about in particular Hyperledger Fabric. That's another form of a blockchain platform, right? It's a permission blockchain platform from Linux Foundation. So I'll talk about introduction of Hyperledger Fabric, how the architecture, transaction workflow happens, and so on. Once I give the introduction about that, then I will jump into hands-on session where I try to set up one sample Fabric blockchain, Hyperledger Fabric blockchain, and show you what can be a simple smart contract and how to use a smart contract and run your transactions. So that's towards the end of my talk. We'll see that demo. So let me first jump into the general introduction to blockchain. So what's a blockchain? By the way, most of you might have heard most of this or part of this content, but just for the sake of completeness, you might find some redundancy, but I request you to still bear with me, right? So I try to keep it a self-contained talk, so that's why I just want to give you this warning that there may be some redundancy with other talks that you are hearing, but please bear with me. So what is blockchain? Blockchain is a shared distributed ledger. And what are the important features of blockchain? So it's a shared and distributed ledger, right? And we need a consensus among the participants. So before any transaction block gets added to the ledger, there should be a consensus. The participants of the blockchain network should agree upon the block that gets added and also the transactions that are included as part of the block which is getting added. Immutability. Data once added to the blockchain, maybe I will open my pointer here. Okay, immutability. Data once added to the blockchain can't be changed. And how it is achieved? It is achieved by associating hash of the previous block inside the current block. So you will have a hash chain where each block will refer to the hash of the previous block. Hence, if somebody wants to tamper this hash chain, unless they change the content of a block and all the subsequent blocks, it is impossible to make any changes. So it's very hard to ensure that doing a change in a current block and all the subsequent blocks, and also ensuring that, okay, your hash doesn't break, right? So that's the part which actually contributes to the property of immutability. In fact, this aspect of immutability is not new for the computer programming world. In computer programming, we have a named constant. It is a value that can't be altered by the program and associated with an identifier. Just I'm trying to draw an analogy between the immutability in blockchain and also what we already know, the named constant in computer programming. So this is also immutable, right? So once you have a value for that, it cannot change its value throughout the course of its life. So it's something similar to that. Next feature is finality. In public blockchains like Bitcoin and Ethereum, the same transaction might get included in different competing blocks proposed by the different peers of the network. State is consistent with certain probability, but there is a threat of forks. So what can happen is that only after certain number of blocks getting committed to the ledger, then only we can consider a given transaction state being final, right? So even though a transaction gets added to a block in a blockchain like Bitcoin and Ethereum, what happens is that you cannot ensure that the transaction is already into the block, into the blockchain. You need to wait for the confirmation of follow-up at least 6 number of blocks in case of Bitcoin, and this number changes in Ethereum. I think it is about more than 10. So you need to wait for those many number of confirmations before you can assume that, okay, the transaction is now part of the blockchain, right? In contrast, there are a different class of blockchains where the finality is guaranteed as soon as the transaction is included into a block. For example, Hyperledger Fabric. So here in Fabric blockchain, whenever a transaction is added into a block, it is for sure given that it is they're going to be in the part of the blockchain for the entirety. So this is one aspect that is different from different blockchains, right? And provenance, place of origin of history of ownership tracked via chronological sequence of events. So this is provenance, and it is possible to track provenance of different resources, right, which are being tracked in blockchain using a blockchain network, because we have the immutability property. So you can actually link the different events that are happening throughout the life course of the life of a specific resource, and that's how you can track the provenance. And there are many applications actually for which blockchain typically is used for the provenance tracking. This is very useful property of blockchain that makes blockchain usable in many different real world applications, right? So these are the basic features of blockchain. There are different types of blockchain actually that we have around. For example, something called permission blockchains and permissionless in terms of membership permissions. So this is one category. A blockchain can be permissioned or permissionless, and it can be a private or a public blockchain in terms of ledger accessibility. For example, Bitcoin, it is a public blockchain network. Anybody can access the network. So on the other hand, permissioned blockchains typically keep the ledger private to only the members who are part of the network. So anybody who is not a member of the blockchain network typically won't have access to the blockchain ledger, right? Only the intended parties. Even inside the network of participants, it's possible to make arrangements such a way that only the intended parties will have access to the data. So that's what is the, I mean, and this ensuring privacy of data actually has many different methods in different blockchains, right? So it's not generic, by the way, right? So next is permissionless blockchains. Let's little bit look deep into the permissionless blockchains. So what permissionless blockchain means? Anyone can participate in the blockchain network and add a transaction. So there is no need of having a specific identity. What it also means is that, for example, in a Bitcoin network, I can use a specific identity and add a transaction today, and tomorrow I can have a different identity and add a different transaction. So nothing prevents me to have two different identities and add transactions to the network. And this ledger is public typically, and here consensus is achieved via proof of work or proof of stake or many other different proof of stake algorithms being coming up nowadays. So the main reason for the requirement for one over the other kind of proof of stake or work or a different algorithm is the efficiency, right? And the specific business need in which the blockchain network is being used. So essentially the motivation or goal is the same. We need to have a consensus among the network participants on what are the set of transactions that needs to be included in a blockchain network, and also what are the blocks that needs to be added to the blockchain network. So that's the main objective of having a consensus method, and it can vary. By the way, just wanted to know, you are able to hear me, right?
Yes, we can hear you.
Yeah, sure. And next variant is permissioned blockchains. In permissioned blockchains, in contrast to permissionless, we need a specific identity associated with the participants. So every participant in the network knows who are all the other participants in my network, and which specific user is doing what set of transactions. So everything is tracked and everybody knows who are all the members. And also in permissioned blockchain networks, you require approval to join to the network, and only after you onboard to the network with the proper approval, then only you will start either accessing the ledger or start adding new transactions, right? And the consensus through in such kind of blockchains, the consensus algorithms typically are any Apache Kafka, Vajant and BFT kind of protocols, or many. There are so many other variants of BFT, essentially to achieve better throughput. So that is main objective here. You need to get better throughput, and the more the throughput is, the more usable is the blockchain, right? So towards that goal, there are many new consensus algorithms that are coming up. So next is a smart contract. Smart contracts are common to any blockchain, and they typically capture the transaction logic or the business logic that a specific network participants wants to implement, right? The logic is captured in the form of a smart contract, and the smart contract is installed on all the peers of the network and executed. So everybody can actually have visibility into whenever a transaction is being submitted, what is the type of the transaction, and what is the processing that is going to happen with this transaction. And also for each transaction, what is the input and what is the set of outputs, uniquely and deterministically across all the peers. They can actually see the same content. So that is the consistency, right? So let me take you through some of the popular blockchain platforms or solutions around. Again, this is not the complete list. I'm just taking a sample of it. And one is Quorum. It's an enterprise blockchain network, which is a fork of public Ethereum client Geth. And this is actually started by JP Morgan as an open source project to develop an enterprise Ethereum client. And it's a permissioned blockchain platform. So as I said, this is for the financial network transactions. So it is a permission blockchain network from JP Morgan, and it follows something called UTXO ledger model. We'll see what are the different ledger models and what it specifically means. But at this point in time, just remember that any blockchain platform or blockchain platform can support any of these ledger formats. Either it can be UTXO or account balance model. One of these two, it can be supported. And Enterprise Ethereum Alliance, this is another blockchain platform, which is a permissioned version of again public Ethereum blockchain. And Bitcoin, we all know it's a public blockchain, another famous blockchain platform. And Hyperledger Fabric, as I said at the beginning, this is a permissioned blockchain platform from Linux Foundation open source project. And here some salient points to note is that the privacy is achieved through channels and private data collections. Though we will not see in this talk more details about private data collections, but we will see the more details with respect to channels. So channel is nothing but a shard, you can say, in a public blockchain terminology. It can be seen as a shard where the related network participants come together and communicate using within a channel. And within a channel, all the network participants are typically having access to all the transactions in that channel. And there can be one or more channels. A network participant may be participating. That's completely feasible. And also the scenario is that The private data collection is something that can be inside the channel, where if you want to have additional data privacy, where you don't want to share the specific content of the transaction data to other participants in the channel itself, then you can create private data collections and share the content by having access to the private data collection among the group of participants who need to have access to that specific data. Right, so this is a private data collection is additional functionality within channel mechanism, which provides basically the privacy for the network participants. Right, so we'll not look into this much detail, but this is what it is. You want additional data privacy among the channel participants also, then you use the private data collection to create a group of users with whom you can share a specific data, and that data hash is stored on the channel, the ledger in the channel, so that everybody knows that somebody who is having access to the private data collection can ensure that, okay, this is the specific data shared by the sender, right? And because of the hash, we can always guarantee that. And coming to Hyperledger Fabric, there is another variant is IBP, IBM Blockchain Platform. It is an enterprise version of Fabric. So yeah, so this is another blockchain platform, but this is similar to Fabric. Only thing is the difference is it's an enterprise platform. So because it's an enterprise platform, there are certain functionalities associated or offered by IBP which are not available in Fabric, which are value-added features, functionalities that are implemented to address specific pain points of the clients. Next is R3 Corda, and Corda is a distributed ledger technology, and here it works with the notion called need to know basis, which means that there is no scenario where all the network participants have the access to all the network data. Only groups of participants will have access to the data which is being shared among this group of participants, and you can have a different group of participants who will share a different set of data, and all this data resides on the same ledger, but the access is restricted to only those group of participants who are participating in that specific group. So only on the need to know basis, access is provided to the data to any participant. So in that sense, this is not having revealing access to the entire network data to any single individual. So that's one very important aspect. The reason why they wanted to come up with a structure is that this actually implements the notion of what is called what we know as the smart contracts or regular contracts between any two transacting parties. So they wanted to, as is, take the notion of contract and implement that on blockchain network and provide access to the data that is part of that contract only to those parties which are involved with that specific contract. So that's the reason behind having this notion of need to know basis way of having access to data. And enterprise version is private permission. This is again it's a private blockchain, and it's a permission blockchain too, which means that the network participants need to have an identity, and the ledger is only accessible to those users. The Corda open source, the blockchain platform base code is open source version is freely available for anybody to use and have access to. Right, so these are some of the important blockchain platforms around. So let us see where the transaction execution logic is captured. We know a transaction is a business transaction, and it implements, it has some certain inputs, and it needs to process on those inputs certain logic, and eventually reach to an output, which is again tracked on the ledger, now recorded on the ledger. Now, where exactly this transaction execution logic is captured is nothing but the smart contract. The smart contracts actually help to encode the business transaction execution logic into the blockchain, and the specific smart contract which is of interest to the participants all the participants, network participants of the business network will have access to that specific smart contract, right? So that's how you will achieve privacy. And also, and it's also possible that the smart contract logic may get updated, in which case you can upgrade your smart contracts, change your logic as per the business requirement. Today, the business requirement is so and so. Accordingly, we have come up with the smart contract logic version 1.0, smart contract version 1.0. Now, tomorrow, the business logic is changing for the same specific smart contract. Then you can update your smart contract to reflect to the changed requirement in the business logic, and install the smart contract. And you start using the updated smart contract. And all the network participants will also have access to all the history life cycle of the smart contract, how it is changing and so on. Okay. So just note the fact that any existing transaction which is committed to the ledger using a older smart contract will keep using the older smart contract version only. The existing transactions cannot be using the updated smart contracts. Simply, this is because if you use the updated smart contract, your outputs will change, right? And it cannot happen that you can roll back to a newer output. So you need to associate the specific version of smart contract with each transaction, and that specific version will version of the smart contract that is used for the computation of the output given the inputs will remain the same thing throughout the course of the life of the specific ledger. Right. So next, let us see blockchain. We know is so famous, right? And we know a lot of concepts are there. So let us see what are the concepts upon which the different concepts in blockchain build upon from the study of computer science, right? So we have some cryptography. So for blockchain, cryptography is one of the background areas of domains. So cryptography here, for example, when we talk about digital identities, digital signatures, and the cryptographic hash functions in POW and so on, which are used for the consensus mechanisms, right? So these are all the concepts taken from the cryptography field. So similarly, the consensus protocols itself and the peer-to-peer communications, there are gossip protocols that are used, for example, Fabric for the peer-to-peer communication and so on. There are all the concepts that are taken from distributed computing. And the smart contract. So smart contract is nothing but a program, right? It is written in general purpose programming languages like Go, Java, and so on. So, and we have all the, when we write a smart contract using a programming language, the smart contract is no different from any other program. So when you say a program, you have an input, an output, and you can even debug the program where it is going wrong. For the debugging, you have logging messages, and you need to have error handling mechanisms. For example, so you have try catch blocks, right, in Java. So similar to that, there needs to be the error handling mechanism. What can be the possible errors that you may encounter as the smart contract gets executed? And in the case of certain facing certain errors, what has to be the handling? So all these general programming concepts are retained with smart contracts also, just because smart contract is nothing but a program, software program. So all the programming languages and software engineering techniques apply here too. And the developing and the testing of smart contracts inherits the concepts from software engineering too. So here I'm trying to capture the fact that blockchain is basically, it attracts these concepts from different fields of study in computer science, right? So not just these fields of study, we have few more. For example, database technology. Blockchain is a distributed database with inbuilt trust and transparency. A blockchain transaction need to satisfy all the asset properties, atomicity, consistency, and so on, and game theory concepts, incentive mechanisms that are used for the transaction processing fee in Bitcoin, for example, how the fee needs to be distributed to the miners in case of a Bitcoin network, right? So the miners typically get some fee for the inclusion of the set of different transactions. So, and also some fee because they created a new block. So all this information is, all this fee is collected from the transaction itself. Whoever is submitting the transaction, they need to pay this fee. So this is all, what is the specific mechanism? The different details are drawn from the area of game theory. And similarly, networking concepts. We have TLS cryptographic protocol designed to provide communication in a secure manner between the peer-to-peer, right? So similarly, the firewall management and network connection management between different components and so on. So there are many other concepts. I'm just listing only a subset of the concepts that we use in blockchain network that are pertaining to networking world, right? So these are different concepts that we draw from different areas of research. And what I listed is not the complete list, though. I'm just giving a sample of them. And we need expertise on all these domains if you really want to understand blockchain fully. But if you want to focus in a specific domain, for example, you want to further study how the consensus protocols work, you can actually focus on the different distributed computing protocols, 2-phase, 3-phase, and different protocols, how they are working, and what are the different properties of those things, and so on, right? So you can focus your research in a specific direction in that way. And for example, smart contracts, there are a lot of research papers that come actually, which analyze how the smart contracts efficiency can be, execution efficiency can be improved, or what are the chances. Recently, I saw one paper where it talks about how to ensure that the transactions that get executed may fail or pass, right? A transaction that is submitted into the blockchain network, into a block, may be a successful transaction or a failed transaction. If it is a failed transaction, the transaction owners needs to resubmit the transaction. So what is the desired course of action here? If the blockchain network can guarantee that the number of failures are less, then that is the more desired scenario, right? You don't need to resubmit the transactions again and again as a owner of the transaction. So ideally, you want to ensure that whenever the transaction is included in a blockchain network, you want to have the assurance that the transaction is success. But it is not always the case. So I was looking into some research paper which talks about how can you increase this probability or chance of a transaction being always success when it is included in a blockchain. So that's one area of research which talks about all the software engineering aspects and how you can actually fine tune your system, and different parameters are there for your blockchain network to run. How can you, in a coherent manner, change the different default values for these parameters? Hence, you can ensure that the number of transactions that eventually fail, which are included in a blockchain network, can be reduced, and so on. So these are all different areas of research. I don't want to spend much time on this. Next one is Merkle tree, and it's used in blockchain. If you see a blockchain, any block consists of two components. One is block header and another is block data. Block header consists of the block number and previous block's hash and data hash. Data hash is nothing but the hash of Merkle tree root. We will see what is Merkle tree root and why we need to use a Merkle tree root. And the block data, the concatenation of bytes of transaction part of the block. So this is the Merkle tree for a given block data. So data blocks are L1, L2, L3, L4. Now what we do is we compute the hash of each of these independent blocks. So this is a chunk in the block. So you have a blockchain block, and that block data you may be able to transfer in one single chunk over the network from one peer to the another peer, or it may not be possible to transfer the data as a single chunk, right? You need to further chunk the block data into sub chunks and transfer them. When you are transferring the original block as a chunks of data, how can you ensure that your chunks are not introducing any transmission errors? right? Intentionally or through the introduction of manually by the attackers. So how do you ensure that the block gets reconstructed correctly, whichever the sending peer is trying to send? Right, so that is one important problem. So for that, what we do is that we compute the hash in the following way. We chunk the block, original block, and each chunk we compute the hash. And for these two hashes, again, you can compute hash of these two hashes. And also right subtree, you can compute the hash of these two hashes, and so on till you reach the root. Finally, you get one hash. So the property with this hash is that whenever there is a change in even single bit of data in any of these chunks, your hash at the root will change. So unless the hash at the root matches, the receiving pair won't accept the data. So what the receiving pair will do, it will actually have the block header. In the block header, it knows that what is the Merkle tree root hash for my data. And once it receives the block data over the gossip mechanism from the peer node, it reconstructs the block and it computes the hash and checks whether the Merkle tree root hash is matching with whatever is the block header hash which is specified in the block header. And if that matches, then the receiving peer can accept the data. So that is as simple as that. So, and this is because it's so efficient, even if there is a single bit change in this data that is being passed here, your hash will change, right? So that's so powerful to track the fact that your data that is being shared between the peers using the gossip mechanism is intact, right? So that's why it is used in many other places, not just here. And let us see more into the ledger models of blockchain. As I said, there are two types of ledger models. One is UTXO model, and another is account balance model. In UTXO model, which is called unspent transaction output model, a transaction can split an input into multiple outputs. That is one property. Similarly, a transaction can merge multiple inputs into one single output. So what you can have is that multiple inputs, you can actually club them and generate a new transaction. For example, your multiple inputs means you have the different values, input values 5, 6, 7, for example, and you want to club the value of 5, 6, 7, and 13 and 18, total 18, the value you want to create as a new transaction. You can generate a merge transaction here with these inputs, individual inputs, and create one single output, which is called 18. Now, a new address is associated with this value 18. Whenever you want to use that, that is when you want to spend this value, then you can use 18 directly, and instead of these three different inputs. There is no difference between using these three different inputs or using the single output, but we need this for the following reason, that when you are spending, you need to split. For example, I have value 100 with me, and I need to spend 40 units out of it. Then I will be left with 60 units. So what typically I do is that I will first split my 100 into two values, 40 and 60, and I want to spend the amount 40 units. So I will use the address which is associated with the amount 40, and use that. I will spend that specific amount, and I will be retaining the amount 60 with my wallet. In case of, for example, Bitcoin, how that happens. So each UTXO is associated with an address, and the user wallet tracks what are all the active unspent UTXOs with my wallet is tracked, right? So with all the users, they will have a wallet and they will have a list of UTXOs which are unspent yet. So they can, in any new transaction, only we can use any unspent transaction and spend it. And account balance model. So this is specifically used in blockchains like Ethereum and Hyperledger Fabric. And the state is defined as a key value pair and the associated versions. And a transaction reads the keys with a specific version and writes the keys with a specific version. We'll see what exactly it means. For example, first I will give another important functionality in any of these ledger models. Either it is UTXO model or account balance model, one important property that is to be maintained is ensuring that there is no double spending in any of these models, whether it is UTXO or account balance. It is required if you want to ensure the correct working of a blockchain network. You should have guarantee that no double spending is possible on this network, right? So what is double spending? So for example, I will give a simple example that what is meant by double spending. Alice first executes a transaction T1 to sell her car to Bob, and Alice next executes another transaction T2 to sell her car to Charlie. So there are two transactions here. Alice is the owner of a resource called, which is a car here, and Alice is the owner of the car, the resource, and she wants to sell that car to Bob in transaction T1, and she also wants to execute another transaction T2 where she wants to sell the same car to Charlie. So obviously, because it's one car, she can only sell the car to either Bob or to Charlie. So that means you need to ensure one of these two transactions only is eventually succeeding. It cannot happen that both T1 and T2 are succeeding on the blockchain network. If both T1 and T2 are succeeding, that is nothing but double spending. That means that here Alice is spending the same car, she is selling the same resource car to two different parties. So she is spending the same resource two times. So that's called double spending. And obviously both T1 and T2 cannot be valid at the same time, since Alice cannot sell the same car twice. So it is logical that both T1 and T2 cannot take place at the same time. We need to ensure programmatically when we are implementing the same thing on blockchain that only T1 or T2 at most is going to succeed, but not both of them. It may also happen that both T1 and T2 won't succeed. That's also fine. Then the resource returns with Alice. That means that Alice is unable to sell her car. That's perfectly a valid state. But it cannot happen that both T1 and T2 complete at the same time. So that is the one requirement, very important requirement of any blockchain. And how it is handled in UTXO models. So it is handled by validating the addresses. Whenever address is about to spend, then all the network participants will ensure that this network was never ever spent earlier. So that's how they will ensure. And in case of account balance model, so to ensure an account balance model, there is a technique called MVCC, multi-version concurrency control technique, using which we can do it. Let me give you what is account balance model and how it will change. For example, your ledger state, which is also called world state in the blockchain terminology, the world state contains these values X, Y, Z, and these are the keys. As I said, in account balance model, the ledger is a set of key value pairs and the associated versions. So, for example, your world state contains key X, Y, Z. There are three keys, and key X can be value 10, Y can be value 20, Z can be value 30. We don't need to really care about that. We just say that the current version of the value is V2, current version of value is V3 for key Y, and similarly, current version of value is version 1 for key Z. So we have three keys X, Y, Z, and they have some version of value, version V2, version V3, and version V. This is the current state. Now, there is a transaction with read set. What it says is that I take these two input keys for my transaction, X1, Y, and I have a write set. And my write set is I want to update the key Y to version V4. I want to update the key Y to version V4. So if this transaction is eventually added to blockchain, what will happen? The versions V2 and V3 corresponding to the keys X and Y are held. And there is some transaction execution logic inside T1. We don't care about it. The output is the Y key Y is changed to the version V4. The key X will retain its same old version V2. Only the key Y is changing its version. Now coming to transaction T2, again we have the same some inputs, that is in this case G and Y, and the write set is X is changing to version V3. Now, if we see in this example, both T1 and T2 cannot happen at the same time, because assume that T1 first happens and T2 second happens in a serialized manner. T1 and T2 are executing. Then what we will see? When T1 is executing, it will succeed because the read set X1, V1, Y, V3 are matching, and it can write value of key Y to V4. Now, when T2 is reading, it wants to read a value V3 of Y. But because T1 is already committed to ledger, now the value of the key Y is V4. It's no longer V3. So the read set is failing, right? So T2 cannot execute in this case if T1 and T2 are executing in that order, T1 followed by T2 followed by T1. In that case, only T1 can succeed because T1 is the first transaction which is executing. So similarly, assume that the order is swapped. T2 first executes, then T1. Then because T2 is first executing, we know Z is matching the version with the current world state. It is reading these values GV1 and YV3. So it is matching. So it can write value of X to V3. And because now value of X is changed to V3. Now when T3 is success, T3 is committed. Now when T1 is trying to execute, this read set is not matching. Here X version V2 we need to be read from the world state, but it's already available is X is version 3, V3. So this is not matching. So T1 cannot succeed. So only T1 or T2 in this case can succeed. So this is achieved by, and this kind of comparison is made, and you can have it's up to the your ordering service, which actually are they in case of public blockchain, it's up to your miners in what order they include the transactions into the block. If T1 is included first, then T2, in this case, only T1 will succeed. On the other hand, if T2 is included first and T1 later, then only T2 will succeed. On what basis, which transaction included first is up to the ordering service in case of Fabric blockchain, or in case of miners, and in case of Bitcoin blockchains, it is up to the miners in which order they want to include in a block. Right? Once it is included in the block, then at the time of execution, this is the same algorithm that is followed by all the peers, and they will all either accept T1 or T2 based on the order in which they are included. Right? So this specific technique is called MVCC. Then blockchain perceived benefits. Let's see some of the benefits in different. We know blockchain is used in many different areas, domains to solve the pain points. But let's see some of the generic benefits. It's not again the complete list though. So inefficiencies of today's business networks. Data is held in silos at different organizations. So there is no standardization in the data, many of the domains. So because we are in particular targeting the problems where multiple organizations come together and participate in order to complete a transaction, right? So they need to have visibility into the same value of the data. And there is no standardization in the data. So data organized in different digital formats, and different organizations use different kinds of tools and software. So these are all different differences in terms of the standardization and how data is organized. And most of the time, paper-based information is used for tracking. For example, error-prone. The paper-based data, it is error-prone due to manual processing, and also there can be possibility of fraud and delays due to missing information. Right. So most of the time we can see when we are processing paper-based documents, some data can be missing, and sometimes it can be wrongly mentioned unintentionally as a manual processing error, or intentionally because there is a scope for a fraud. And also the main other problem is that in the today's business world, without blockchain being there, the communication between the peers is pairwise, and lack of trusted information leads to fraud. And there are requirements for a lot of intermediaries in between the data processing from one participant to another participant, actually. And this also creates delay in communication along with consuming process approvals and so on, right? And eliminate unnecessary process cost and wasted time. So blockchain use of blockchain to solve business problems actually helps eliminate unnecessary process cost and wastage of time. So these are all some of the inefficiencies that you can replace. For example, paper-based information tracking, you can now track the same information using digital records on blockchain. So that is one use. And similarly, the communication between peers, right? Earlier, it needs to happen between each peer independently. Now, you know, all the data is there on the ledger, and you know which are the participants, which who can have access to the data, and the respective participants can have access to the data much more elegantly. So some of the fields that can get benefited, one is supply chain industry. It's a proven fact that supply chain industry is one of the biggest beneficiaries of use of blockchain in their day-to-day processings. So create a blockchain ecosystem to share data among the supply chain participants. So for example, we have IBM blockchain transparent supply, which is used for the provenance tracking of goods from the origin to the destination in many different domains. Either it can be food industry, or it can be medical domain, or many other industries. Actually, we have solutions that are providing provenance tracking for the resources or assets that are tracked in network, blockchain network among the participants, right? So supply chain solutions like trustable supplier and so on, food supply chains, right? And international goods trade. This is another biggest industry, goods trade industry. We know that because of the current ongoing pandemic, we see there is a huge hit on the goods trade industry too. And blockchain is actually helping the industry address many of its day-to-day issues. Right. So on banking and financial services, again, we have solutions like WeTrade solution, which is a digital platform to simplify the trading for both the companies as well as for the banks. So it is again consortium of the banks which come together and use the single network to address different pain points for the financial transaction settlement. And this is built on top of, again, on the IBM blockchain platform or the Hyperledger Fabric. And let me just minimize this. There are other domains like logistics and healthcare domain. In the previous talk, we were listening that health pass is one of the solutions nowadays we are using, right? So we hear a lot about. So all those such kind of healthcare solutions, not just the health pass, but also, for example, develop blockchain-based surveillance systems so that public health agencies can more efficiently gather data about patients and prescriptions, right? So gathering this data for critical illness and so on, and ensuring that the prescriptions are properly advised and so on. So these are all very big issues or hard problems in healthcare domain. And there are actually blockchain solutions, actually blockchain-based solutions, which try to address the pain points here. And example, providing data sharing and secure access to patient data appropriately for reference by doctors and hospitals and pharmaceuticals. And this is another solution actually provided or enabled with the help of blockchain. And this is in particular to the healthcare domain. And yeah, there are many other solutions. I'm just trying to capture few of the examples, but essentially there are a bunch of areas which can get benefited with the use of blockchain. So let me shift a little bit towards the specific technologies inside the blockchain. For example, identity. So each participant of Fabric network, we know that needs to have an identity, and it is basically a 509 digital certificate that is used. And this is, by the way, till now we have seen some of the general introduction about blockchain and some different principles and fundamentals. Now we are going to look into a little bit more into the details of Hyperledger Fabric and how it is working, right? Before jumping into the hands-on at the last half an hour. So public, next 30 minutes, I try to cover these things. So public key infrastructure helps manage the identities in blockchain. And when you talk about PKI, these are the 4 different concepts which are important: digital certificates, public and private keys, and certificate authorities, revocation lists. So how PKI work? A requester, the principal which is called, and they request for the certificate authority. The certificate authority issues the certificate. The certificate issuance involves issuance of digital certificate and a public key and private key. And there is something called certificate revocation list, which is maintained with the certificate authority. We'll see. So digital certificate, typically it captures the requester information, namely what is the name of the requester, what is the region from which the requester belongs, the organization, and other details, and public key, private key, all other details in a given format, which is called digital certificate, which actually acts as the identity of the specific user. And whenever somebody is, Mary is, for example, in this example, is trying to share a document, then she will sign the document with the private key, and this digital signature is generated. And the verifiers, whoever is consuming that content, the document, to ensure that this document is actually generated by Mary, they will verify it using the public key of Mary. And if the content is intact, it is not changed in between, then the signature will match, hence the verifier can accept and ensure that this is in fact the data that is being shared by Mary. On the other hand, if any data changes in between, then the verification using the public key will fail. Hence, we can come to know that there is some tampering that happened. And identity CS, CS actually they issue the certificates and public key, private key pair. And so, I mean, there are CS also that there can be not just one specific CA, which is called the root CA, but also there can be intermediate CS, which are called intermediate ICS here, intermediate CS. The main reason to have this intermediate CS is that if we have only single root CA, then the load needs to be distributed. Hence, for distribution of the load on the root CA, we can have any number of ICS. How the ICS will work is that root CA can actually sign a certificate and issue that this specific individual ICA1 can act as a intermediate CA now. Now, the intermediate CA also can start issuing certificates to the clients. Similarly, the root CA and the intermediate CA can also actually issue certificate and say that it can actually instantiate another intermediate root CA, and this chain can keep happening. So all these intermediate CAs, certificate authorities, and the root CA, RCA, all of them keep issuing the certificates. When they issue the certificates, how the validation will happen? So if the root CA is directly issuing the identity certificate, root CA will validate. If root CA is issuing the intermediate certificate and that intermediate certificate authority is issuing an identity, then we have to validate the root CA will, the intermediate certificate authority will validate the ID which is issued by itself, and the specific ICS certificate will be validated by the root CA. So we need to have a 2 level of validation, and similarly any number of validation based on the specific intermediate CA which is issuing the identity certificate. So we have to have this validation. Only then we can ensure that the specific certificate is correct. And what is the revocation list? In some cases, actually, you may compromise your public key, private key, right? In that case, somebody else is also having access to your private key and public key. So you don't want to, going forward, don't want to use that specific key pair for your certificates. So you will intimate the certificate authority that somebody has stolen my private capability. So let's not use this as a valid key pair for on behalf of me. So then in that case, it will be added into the certificate revocation list. And whenever, so note that each certificate has a life. After a certain period, certificate will expire. And this revocation list is different from certificate being expired. Right? So that is very important to note. Yeah. So whichever certificate is part of the revocation list, the certificate authorities will ensure that some impersonating principals or somebody who has stolen your keys are not going to use those certificates on behalf of you. They will ensure that. So that's the revocation list. So next is membership service provider, MSP. This is very important aspect in Fabric, right? In any, for example, in Fabric blockchain is one very important aspect. What it says is that you can have many different identities, but what are the specific identities that I am going to accept in my network, and what are the roles that I want to associate with these identities in my network? That's what is called the identity mechanism. So here, I want to explain this using one simple example. For example, you went to a grocery shop, and then in that store, you may, as a customer, you may have access to different credit cards, right? You can have ICICI bank credit card, HDFC bank credit card, SBI bank credit card, and so on. Citibank credit card. You can have many different credit cards, right? So, but what happens is that the store owner, they may be only accepting, and they may fall under many different categories, right? Visa, Master, and many different categories. So the store owner may only accept certain types of cards. Only Visa cards I want to accept. I don't want to accept MasterCard. So that is the store owner's requirement. Now, even though you have many different identities, you can only use the specific identity which is now provided by a Visa, and you can use that. So your MSP is it's analogous to this example. Your MSP will ensure that what are the identities issued by which specific certificate authorities I can accept in my network, and what role I can associate with that specific individual. So that is ensured using MSP. And we can have in Fabric network two types of MSPs. One is local MSPs, another is channel MSPs. So local MSPs are typically associated with the clients and with the nodes, that is peers and others. And the channel MSPs are administrative, and they they provide actually details about the they define the details for the network participants in the network. So each MSP is maintained on the local peer, that is the node on the files on its file system. And if it is a channel MSP, even that is maintained in the local file system of the peer. But in case of channel MSPs, the different MSPs across different peers, they get synced regularly at periodic intervals, so that all the MSPs have the same view. So this is one example of how MSPs are configured in a Fabric blockchain network. So here we can see this bigger box is the blockchain network itself, and C is the channel. And in a channel, we have one ordering service, which actually orders the transaction and cuts the path. And we have the peer nodes, one or more peer nodes. We have one ordering service, and we have the certificate authorities, CS here, root CS, and channel. And these are the MSPs. The MSPs are associated with the ordering service. For example, here with the peer, we have a local MSP. With the ordering service, we have a local MSP. So what it means is that this MSP will help the peer to define what are the different client IDs I can accept as the client for my peer network. And similarly, this org MSP is associated again with the different channels. Here, for example, this channel has ARC2 MSP and ARC1 MSP. So they are the global MSPs. So because it is a global MSP, with each network participant, this specific MSP is maintained. And this defines what is the role for a given identity in the network, in this channel. So that is maintained in the global MSP. And all the peers which are maintaining this global MSP will keep syncing and ensure that they have the same view. So let's see node organization unit and roles of MSPs a little bit more detail. So the Fabric CA, CLI or SDK will have the breakup of organization unit in the following way. The affiliation. So the identity will have information details like what is the affiliation, what is the department, and what are the roles, whether it is peer, client, or orderer or admin. These are the 4 different roles of any participant in the Fabric network. It can be a peer, it can be a client, it can be orderer or admin. And this is the MSP structure. This is the content of the file system component pertaining to MSP that is maintained with every peer. Just one point here with the MSP structure is that the key store, there is a folder called key store, which will store the private key for the different users, or it can be admin users or regular clients and so on. But this key store can be replaced with a hardware security module if you want to have greater security in your network by the use of HSM. In that case, the key store here will be empty, and each time you need a private key, will consider the HSM, and whatever is provided by the HSM, that will be used. So that is also possible. You can associate HSM module with MSP as well. So when it comes to blockchain with the Hyperledger Fabric, so again, this actually provides you all the functionalities like consensus, immutability, finality, and provenance, which we talked about. And it's a Linux Foundation project we already have seen. And Hyperledger Fabric, it is an implementation of blockchain technology that is intended as a foundation for developing blockchain applications. Some of the key functionalities of HLF is Hyperledger Fabric are one is a shared ledger and the smart contracts implemented as chaincode. The smart contract is called chaincode in HLF world, and privacy and permissioning through membership services. MSPs provide privacy and permissioning, just we are talking about it, and modular architecture and flexible hosting options. We'll see more about it soon. And the HLF blockchain platform, the first version is released sometime in 2017, and IBM is one of the contributors. And there are, to begin with, about 27 different organizations who are contributing to HLF, and now this number is very high. And overview of Hyperledger Fabric design goals. It is constructed with these following design goals, like better reflect business processes by specifying who endorses a transaction, and supports broader regulatory requirements for privacy and confidentiality, and scale the number of participants and transaction throughput, and eliminate non-deterministic transactions. So this is a generic requirement across any other blockchain platform, that they don't allow the non-deterministic transactions, simply because of the reason that if there is a determinism during the transaction execution, then the peers may end up generating in different states. So the consistency among the peers state cannot be ensured if there is a non-deterministic execution behavior. So typically they prevent transactions with non-deterministic behavior to be included in the blockchain. support for rich data queries of the ledger. This is achieved in Hyperledger Fabric using something called CouchDB. Hyperledger Fabric by default comes with the format called LevelDB. It's a library, LevelDB. When you replace LevelDB with CouchDB, then you can actually fire queries which are more sophisticated, not just querying a key. Instead, you can even execute queries like range queries and get response for the range queries too. And another functionality design goal is that dynamically upgrade the network and chain code. As I said, the smart contract earlier, the smart contract actually, the logic business, the smart contract is implementing a certain business logic, and the business logic might change today. So you want ideally to gracefully update your smart contract to reflect to the changed business logic and keep using the upgraded version. So that graceful upgradation of the smart contract version from older version to new version is supported without restarting the blockchain. That's one design goals. And support for multiple credential and cryptographic services for identity. There are many different ways you can achieve your identity, and support for bring your own identity. So all these are all value-added functionalities though, but so all of them I'm just listing here, but we probably may not be going too much deep into each of these functionalities, right? So let's start looking into the Hyperledger Fabric network architecture. So the architecture of the Fabric network, these are different components and modules part of a Fabric network. Let's start with the component peer. Peer is a node which is participating in the network, and the peer can participate in two different roles. It can be an endorser or it can be a committer. And each peer actually maintains these three different components like ledger. It has access to, it maintains a ledger locally, and a chain code. This is nothing but the smart contract. There are smart contract A and B and so on. And events. When the transactions are executed and added to the ledger, it can generate certain events, and to notify, for example, an event to notify the submitter of a transaction and that the transaction got included in the blockchain or not, right? So that can be an event. And similarly, you can even customize what type of events you want to generate on the occurrence of certain scenarios in your transaction execution. And you can, the advantage with this event mechanism is you can have a client which listens to these events, and based on the occurrence of these events, you can actually trigger some other business logic in your bigger application, right? So this is the typical components in a peer. And we'll have an ordering service, which is the core module in the blockchain network, which is responsible for the creation of blocks and cutting the new blocks by including the transactions which are submitted by different clients, not just one single client, but many different clients keep submitting transactions to the ordering service, and it will collect all the transactions from different clients in a given channel and creates new blocks. So another important component is membership service provider, which we have seen in Fabric CS and external CS, certificate authorities and membership service providers, which are used for providing identity and access permissions. So how the application can work with Ledger. This is the architecture of how an application will work, interact with the Ledger. So you can see that this is the peer node, that is, which is part of the blockchain network. One single peer will have this format, that it has internally a ledger, and the ledger is essentially two components. One is the world state, and what are my keys and what is the latest value for each key. Going back to the account balance model example, we had keys like X, Y, Z, and latest versions like V2, V3, and V4. So that specific key and associated version is maintained in the world state. And you have the blockchain anyway, which is a set of blocks, and with each block is a set of transactions. So you execute these transactions one by one. Again, you can reconstruct your world state. So because it is cumbersome to execute each transaction every time and construct what is the my value of a given key, whenever that key is being referenced, if I start doing that, I might end up traversing the blockchain every time. Hence, it is an efficient mechanism to maintain the world state separately, which will maintain what is the latest value. So whenever some client is submitting to the smart contract a query via the client SDK, so this is the client application, which can be in, for example, in a Java language, and it is a Java SDK. And client is submitting a transaction, which is a query transaction, get transaction. Then that is referred to the world state, and it will fetch the specific key value being fetched and respond to the client. On the other hand, if the user is submitting a transaction via the smart contract, like put or delete, that require addition of the transaction to the ledger, then the ledger is updated and also the world state is updated. For the get transaction, typically the ledger is not updated. The get transactions in Fabric are not added to the blockchain ledger. Anybody can query and get a response for a key as long as they are entitled to get that. But those query transactions are not included as part of the blockchain. Only the invoke transactions, which are called put transactions, and delete transactions are included in the blockchain ledger. Okay, so the blockchain ledger, as we have seen, there are two components. One is the world state and the chain of blocks itself. And the chain of blocks starts with something called the Genesis block. So this is the 0th block in any Hyperledger Fabric block. So it is actually maintained for configuration purpose. So it will not contain any user transaction. The user transactions are included from the block number 1. And this is the reference pointer. This is previous block hash, which is maintained in the header of each block that we have already seen, and the block number. Along with this, we have Merkle tree node hash, also the data. So these are the values that are available with each block. The transaction, each transaction will be associated with a read-write set, right? The read set is nothing but what are the keys that are used as part of the processing my current transaction. That is the read set. And write set is once I execute the smart contract logic using these read set values, what is the output that I'm going to generate is called contributes to the write set. And the world state can be either level DB or CouchDB, as I said. Level DB is simple key value pair, and CouchDB can support sophisticated range queries kind of stuff. The smart contract actually decides what is to be written to the world state, and whenever something is written to the world state, that is written to the world state in agreement with all the participating entities, right? So it is not all the participating in true sense. We will see what it is called the endorsing peer. So in Hyperledger Fabric, actually, certain peers are only responsible to execute the given transaction and generate the output. And the output that is generated as part of the endorsing peer transaction execution must match across the execution of the same transaction by different peers. So there can be one or more endorsing peers which will execute the transaction, and only if all of them are able to generate the same output, then only the transaction is treated as valid and will be included in the block and will be updated on the ledger as successful transaction. if the different endorsing peers, for example, there are two different endorsing peers, and for a given input transaction, the two endorsing peers output different outputs, then the transaction cannot be submitted by the client. We'll see the workflow. So nodes and roles. Peer is what is the node in a blockchain network in Fabric world, and it maintains the ledger and state. As we have seen here, the ledger and the world state both are maintained with each peer, and it commits the transactions and may hold a smart contract also. You will see that it's not necessary for each peer to hold a smart contract, right? So only the something called committing peer, they will only have the smart contract. The other peers which are not committing any block of that specific transaction type, they don't need to have the smart contract. And endorsing peer, we have just seen these are the special nodes which execute the transaction and generate the output. And they must hold the smart contract because they execute the smart contract logic using the input submitted by the client and generate the output. Hence, they should have access to the smart contract. Then ordering service nodes. This is again a quorum of participants act as ordering service, and they actually are responsible to ensure that which are the transactions which are included in a block and what is the sequence of blocks to be included in the network ledger. So this is the ordering service node. In particular, Hyperledger Fabric follows this transaction execution principle called endorse, order, and validate. This is in contrast to other blockchain platforms like Bitcoin, which follow the paradigm called order and execute. Therein, for example, the miner actually orders the transactions, and each of the peers who are receiving the block, they will execute the transactions. And they execute the transaction because the transactions are deterministic in behavior. All the executions of the transactions will lead output the similar values on all the nodes, either peer 1 or peer n or peer 10, whichever is executing the given block. They will take the same input and they will generate the same output in a deterministic way. Hence, the consistency of the ledger is maintained across all the peers. In case of Hyperledger Fabric, it is a different mechanism. It's a three-step process where endorsing is something called the endorsing peers will do. Then ordering will happen, which is performed by the ordering service node here. And then validate. Validate is performed by any other peer. So these are the three different roles. So first is endorsed by the endorsing peer. Any transaction that is submitted by the client is first endorsed, and then it is being ordered by the ordering service. And then finally, when the blocks are received by all the network peers, they will validate before committing the contents, the transaction output to their respective ledgers. So let's see in more detail what is the transaction life cycle in Fabric. So the first of all, the client application interacts with the SDK. It can be Node SDK, Go SDK, and so on, based on your preferred programming language in which your client application is written. You will submit the transaction proposal. This is called submitting the transaction proposal. I want to submit this transaction, and you propose that with all the endorsing peers. Here, let us see a little bit about what are the roles and the coding with each of these modules. One is endorsing peers are referred using this blue box, and committing peers using this gray box, and ordering service nodes, this green box, and smart contract. So these are all the smart contracts, and this is the endorsement policy. We'll come to this later. Then the application, this is the application as such, and we have the ledger. Ledger is the chain of blocks, that is the ledger. So these are the different components. So client application submits a transaction proposal for smart contract A. So we want to now execute a transaction where the transaction execution logic is captured in the smart contract A, and it must target the required peers E0, E1, and E2. It's also mentioned in the channel. For example, assume that on the channel, because all these participants, we have here, how many peers are there? We have E0, E1, E2, all these are also peers only. But only the difference is that they are peers. In addition, they have this additional role that they are the endorsing peers of this channel. So these are same kind of peers as P3 and P4. Only difference is that these peers have additional role that they are the endorsing peers too. So we have 5 peers, and we have 3 different types of smart contracts here, A, B, and D. Right. So A is with these 3 peers and P3. P4 is not having any of these smart contracts, and P3 on the other hand has a different smart contract, and all of these have in common to smart contract A. Now what we are trying to do, a client is trying to submit a transaction for the smart contract A, and it submits the transaction to these 3 endorsing peers. So first the transaction submitted to the client should get endorsed by these endorsing peers. Only then it can be a candidate to be added to the ledger. So first it will send the proposal to the endorsing peers. How it knows? It knows from the channel configuration who are the endorsing peers for this channel, and accordingly it will submit. The second step is the endorsing peers execute the transaction proposal, and E0, E1, E2 will execute the proposal transaction, and they will generate the output for the transaction independently, and they even sign the generated output and send it back to the client. So that is the third step. So the second step, they execute each endorsing peer independently executes the transaction, generates the output, and then in the third step, they will send their respective outputs by signing the output back to the clients. The fourth step, the client will validate the output received from these endorsing peers. It will check whether it has received all consistent output. If it is there is no consistency between these outputs, then that endorsements collected from these endorsing peers cannot be used. So client needs to resubmit the same client transaction proposal to these endorsers and collect the output back from them. Only in the case the output matches, then it will proceed to the next step. In the next step, it will generate one transaction proposal, which will include what are the inputs, what are the outputs collected by the endorsers, and the signatures of the endorsers, all that information, and submits to something called the ordering service. The ordering service, it collects not just this transaction proposal, but many other transaction proposals from the other clients, and cuts a block, new block. So that is the ordering services responsibility. At the time of cutting a new block, ordering service also does some validation, like whether this client is a valid client for this channel or not, by referring to the MSP. Because each ordering, as we have seen, MSP is associated with all the network peers and ordering service. So they will refer and ensure that the client is a appropriate member for this channel to submit a transaction. So once ordering service is creating a new block, it will disseminate the block to all the peers in the network. So it will, engaging in a broadcast, it will disseminate the newly created block on this channel. So all the channel participants, they will come to know this is the block, and they will do validation, and they will add the updated values to the ledger. So here star in each of this block here, that is the new block. You can see that earlier there is only 3 blocks in the ledger. The new block is being disseminated. Every peer has only 3 blocks till now. Now every peer is receiving a new block, and validating that block. Only after validation passes, it includes the new block to the ledger. Now note that even though there are certain transactions part of this new block, not all the transactions may be successful transactions. Few transactions may fail. This is because of the MVCC check that we were performing earlier, that I explained earlier. The MVCC validation, if that is validation is failing, the transaction is marked as failed and included in the ledger. But the transaction as such is already included in the block by the orderer, hence it cannot be removed from the block. It will be part of the block, but it can be success or failed transaction. So that is determined by the MVCC validation check performed by any of these committing peers. And finally, the block is added and transaction is included in the block. A notification is generated to the clients. So the client can subscribe to the notification, will have access to the notification and come to know whether my transaction is success or fail. If it is success, well and good, proceed to the next transaction. If it is a failed transaction, then it may decide to whether to submit the same transaction or it needs to drop that transaction. It's up to the business logic there. So overall, this is the transaction execution life cycle in case of Fabric. So each transaction goes over these different steps. First is the client will submit the transaction proposal to the endorsing peers. Here we can see endorsing peer 1, 2, 3. 3 peers are there, and this is the client. The client here is step 1 is submitting the transaction to the endorsing peers. Now the endorsing peers, each peer will independently execute the smart contract, generates the output, and responds back to the client with the transaction output. So that is the second step. So here you can see EP1 endorsing peer 1 and EP2, EP3, all of them are responding back with their signature on the output. They simulate the transaction first locally, and then they send back the output to the client. The clients will collect all these outputs and will perform the validation, the following kinds of validation. That is, first is whether the signatures are proper or not, whether it is getting the appropriate output from the intended endorsing peers or not. That's one thing. The second thing is it will check whether the endorsements are matching or not. So if both the validations pass, then it will create a transaction proposal in the step 3 and sends back to the ordering service. So ordering service upon receiving many such transaction proposals from different clients will include the transactions in certain order as per its own internal algorithm, and creates a new block. And once the new block is created, that block is disseminated to all the peers in the network. For example, in step 4, you can see that all the peers are, whether it is just committing peer or it is an endorsing peer, all the peers will get the new block. Once the block is received, all the peers will validate and commit to their ledger. So this is the overall transaction execution workflow in case of Fabric. It's very important to understand this specific workflow because I mean, this is what we even exercise in the demo next. Okay, so let me kind of prepare you for the demo by a little bit going over some of the configuration specific details of the network setup. So the first one we start with is the ordering service. The ordering service can be, there are many different, as I said, one of the design goals of Fabric is that it needs to be flexible to host many different variations of deployment possibilities. And one such possibility is having a quorum of participants or a single solo ordering service. So typically, we don't recommend use of solo ordering service in production environments, right? Only a quorum of participants needs to participate in the ordering service. For example, Kafka protocol they can use for the ordering service, which requires minimum 3 nodes or 3, 5, 7, and so on. Or it can be for a development environment, you can have a single solo node acting as the ordering service too. So you can configure this. For our experimental purpose, we'll go with the solo. And channels, we can have one or more channels in our network. And as I said, multiple channels can be using the same ordering service for ordering the blocks in the ledger. But when it comes to the ledger specific maintenance, the ledger will have its own ledgers separately. Here we can see two different ledgers. One is red channel corresponding ledger, and one is block channel corresponding ledger. And here E1 is not part of the channel block corresponding ledger. So it is only having ledger for the red channel. E1 is not part of the block channel, hence it is not having the block channel ledger. Whereas the point to note here is that multiple channels can make use of the services of the same ordering service. Note that in Fabric, the ordering service is not bothered about what is the transaction, what is the execution logic, or what it means by the input and output. It only considers the transactions in certain order and creates the blocks. It won't have access to, even if your inputs and outputs are encrypted and provided to your ordering service, it can still order the transactions because it simply don't access that information. And also it is possible to note here that we can each peer can participate in multiple channels, and chaincode is installed on peers to access the world state, and chaincode is instantiated on specific channels. Only the peers which are having the chaincode being instantiated, they can act as the endorsing peers, for example, because only then they will have access to the smart contract. Hence, instantiation is some terminology that we use in Fabric. Installation means that chaincode will be installed, hence you can access the different blocks of the ledger. Whereas instantiation means you can really start contributing by submitting transactions and so on. Here is an example of a single channel network. So here, because it's a single channel and we have only one ledger, note that even though we have one ledger, we can have multiple smart contracts. That means that transaction of type A can be part of your ledger, transaction of type B can be part of your ledger, and so on. Right, so one ledger, but n number of 4 different smart contracts, and you have all the peers can be endorsing peer, like in this example, and all of them will also be committing peers. That means all of them will receive the block from the ordering service and commit to the local ledger. And we have some endorsing policy. We will talk it later. It's a multi-channel network. On the other hand, in this we are seeing in the multi-channel network, actually here we can see 2 channels are there, red channel and a blue channel, and the peer can participate in multiple channels, and the data which is in the red channel is private to red channel, and similarly the data which is there in the blue channel is private to blue channel. You cannot actually have a ledger shared across 2 different channels. Ledger is local to a channel. But of course, it is possible to note that it's possible to query the ledger from one channel to another channel. You can have a query transaction, which is querying one channel to another channel, red channel querying the blue channel. If it knows a specific key in the blue channel, it can query the value of that key and get the access to the value. And you see Fabric peer in more detail. Peer will have all these components when it is executing. So first, peer will have access to 1 or more channels. Here we are saying 3 channels, blue, red, and green. With each channel, we have the blockchain, the ledger, and the world state. So with each channel, with the blue, red, green here, we maintain this separate set. And there can be one local MSP which will provide details about what are the private keys and so on for the users and admins of the peers. And the peer will also have chain code specific to each channel. What channel, which chain code is installed, all that information is maintained with the peer. The client applications, the client application will have again information about what channels I need to communicate with, and what are the different events that I can expect from these channels and so on. And also client application will need to have access to local MSP, only then it can have identity associated with the transactions being submitted, and hence the transactions can be accepted. So it needs to have access to the MSP as well. And Fabric CA certificate authority, which is the global CA in case of Fabric, which actually provides identity for all the participants, either it can be admins, users, peers, or endorsers, any user, right? So it is the Fabric CA which provides the identity. So let me jump into maybe few of these things we'll see. This is the order in which we will configure the network. First, we will start ordering the ordering service, and then we will keep adding the peers. First, we have the ordering service in the network. Then we add the peers. Then we associate the roles with each peers, which are the endorsing peers and which are the committing peers. So committing peers won't execute the transaction. Only endorsing peers will execute the smart contract and generate the output. And what are the smart contracts part of each of these endorsing peers? So endorsing peer here in this case, all of them are endorsing all the smart contracts, right? But in a given scenario, different endorsing peers may be associated with the different smart contracts. And what are the channels in the network? We have yellow, blue, and green. These are the different channels. As I said, the same ordering service can service different channels in the network. Whereas the peers and the endorsing peers, they can be specific to each channel. Of course, they also might be participating in different channels, but it is possible we can have one single ordering service in the network which offers its services to all the different channels. And here we define who are all the members of which channel. For example, yellow channel, we ensure that only E2 and P3 are the members of the yellow channel. Here E0 and E1 are members of the red channel. On the other hand, all these elements are peers, entities are part of the blue channel, right? So, and in each channel, we need to have at least one endorsing peer, right? Only then any new transaction that is being submitted can get executed, and we generate the output and which can be written to the ledger. So we need to have at least one endorsing peers, and also it is possible to have one or more endorsing peer in any channel. So all that needs to be specified. So this is achieved using the peer join channel join command. So here, yeah, maybe I forgot to tell you a mapping. So the first one is that when peer will start node, it will ensure that we will have information about which channel it can be part of, and it will join that. First peer is starting, so that's where we will start the peer, and then we will install the chain code with appropriate peers, and then we will create a channel. Here 3 channels are created. Use the command channel create to create the channels. We will exercise these commands in the next 10 to 15 minute time, and later we will join the channels. So which specific peer needs to be part of which channel? It's all available part of the artifacts configuration information, and using that information we can join the channel. Without a proper approval, you cannot join any channel randomly, right? So that we know. And then we will instantiate the chain codes. So once the chain codes earlier were installed, now we can instantiate. At the time of instantiation, you need to specify what is the endorsement policy. So here endorsement policy can specify whether one of these endorsing peers needs to verify any incoming transaction, or all of them needs to verify it. So that is the endorsement policy. You can mention that one of E0, E1 and E2 can verify on the blue channel, or E0 and E1 can execute the transaction on the red channel, or both of them needs to execute on the red channel. The information is specified in the endorsement policy. Accordingly, when client is submitting a transaction, it can submit the transaction. For example, the endorsement policy says that for the red channel, one of E0 or E1 needs to execute the transaction. Then the client can choose one of the endorsing peers, either E0 or E1, and submit the transaction for endorsement proposal collection. And the respective chosen endorsing peer will execute the client proposal and generates the output and respond back to the client. So that is sufficient. On the other hand, if the endorsement policy is an end policy, then the client needs to send the proposal to both E0 and E1. And in that case, client needs to collect the output from both these participants, right? So that is all mentioned in the endorsement policy. So with this, actually, we can jump into the hands-on session. So the samples, Fabric samples repository is available at this GitHub location. So I actually checked out the same location, and I am using a specific version of Fabric called 1.4.3. You can now even have 2.2.1. That is the latest release you can use the samples from that too. But I have been using this for my own hands-on. I'm using 1.4.3. There are certain features, unless you want to use those features, you can use any of these versions, right? So because in this scenario, we are going to demonstrate only sample blockchain network, how to create and submit transaction. So we can use 1.4.3 as well. So I will stop sharing this and start sharing my system where I'm executing the commands. Okay, can you see my screen?
Yes, we can.
Okay, okay. Okay, let me just clear the network if anything is there. Okay, so the Fabric samples repository that I have downloaded is this one, and I am using release version 1.4.3, and in this there are many different examples here. I will first go with the first network example. And for the first network to run, there is a script called byf1. If you run this script, right, I will just show you. Maybe once I want to set up the network manually by running some of the subset of commands from this byf1, and later I can show you. You can even run this command, run this script, use this script to run your network and exercise, do experimentation, right? So first, before starting everything, you need to have some of the binaries which are called platform binaries. So which I already downloaded. Again, in the location that I mentioned, you can come to know in the documentation that they provide from where you need to, you can download the binaries. And these binaries should match with the specific Docker image versions that you are using. For this example exercise, we are using version 1.4.3. Hence, you should be very careful that the binaries here are also the same versions. For example, if I see peer, you can see the peer version is 1.4.3. The fabric version 1.4.3 corresponding binaries I'm using. If you are using a 2.2.1, you use everything accordingly, right? So that's what one thing I want to mention. The first thing is that you will first generate the crypto materials using this command cryptogen. So for this, what you do is crypto config. This is the configuration file. What it says is that your ordering service, you have an orderer, and there are 5 peers we are using, and the peer organization. Peer organization's names are arg1.example.com, and you have 2 peers under this organization. So what it means is that your blockchain network will have different organizations, right? Each organization can have 1 or more peers participating in the network. So here the count 2 says that we are using 2 peers of arg1 participating in my network. Similarly, users is one user, and similarly there is a arg2, and for arg2 also we want 2 peers from arg2 participating in the network, and count of users is 1. So total 4 peers should be there in our network. We will see whether we will get those many. And also I want to show you that some of these directories get populated as the course of exercising some of these commands. So first is channel artifacts. Right now it is empty. So first I will run this cryptogen. So it will generate the crypto material artifacts using this script cryptoconfig.yaml, which I have shown. So as part of this, you can see that the crypto config directory got created. Now, if you see what is inside crypto config, we have order organization specific information here. And the name is example.com. That's what we mentioned in the YAML file, cryptoconfig.yaml file. In that, all these crypto materials, the certificate authority, MSP, orderers, TLS, transport layer security, and what are the users, all that is information is available. And coming to orderers, if you see, we can say order 2, 3, 4, 5 orderers are available here. That is because in the crypto config, if you recollect, I shown 5 orderers are mentioned. Hence, we have the details for all the 5 orderers. With each order, you can have what is the MSP detail, what are the certificates, and so on. The key store, as I mentioning with the MSP, this key store can be replaced with the HSM module if you have a hardware security manager attached to, right? So, and the certificates here. So all this information you can actually see. So everything gets generated. Now the second one is similarly, you want to know with the peer organizations too. We have arg1 and arg2, 2 organizations, and with each organization there are 2 peers. So if you see peers, we see peer 0 and peer 1. That's what is mentioned in the configuration file. So similarly with the arg2 as well, we have 2 peers. Corresponding to each peer, we have the artifacts generated. So the next one is you execute this, which specifies that what is your fabric configuration path. The current directory is your fabric configuration path. Then you generate something called the Genesis block. As I said, Genesis block is the first block in your channel. So in this, there is no transaction, user transaction is included, and the this is the first block, right? With any channel, you need to specify what is your first channel or first block. And you can now specify what is the name of your channel. So here in this example, it is taken the my channel is the name of the channel. So because you are generating this crypto material, which will be actually used at the time of creating channel, you need to have association between what materials we are using and what is the channel name which you are going to consume this material, right? So that's why we specify this here. Now, so this is the channel configuration transaction. If you see channel artifacts, there are two outputs that are generated, genesis block and channel transaction. This genesis block is generated as part of the previous command here, genesis block command here. And the channel transaction is this specific transaction. This is called configuration transaction. It is a special transaction. It is which is different from the user transactions which get added to the ledger. So in fact, in Fabric, there is a special ledger that is maintained internally, which is the configuration ledger. And this transaction actually is added to that configuration. So whenever there is a change in the configuration or new configuration is created, this channel transaction is used in order to do any modifications. For example, the number of block and the number of transactions in a block, that can be a channel configuration transaction. Initially, we started with 100 transactions in a block, but you want to now change your number of transactions in a block to 200. Then you can create a channel transaction and submit that, and according to the channel configuration transaction, internally in the ledger, this block gets added, and all the peers will start now seeing any new block with 200 transaction, right? So this is channel configuration transaction. So we will need a channel configuration transaction. Why it is used is that channel transaction configuration transaction will initiate the ledger and will let the participants know that this is the genesis block and this is the start of the ledger. And okay, so channel transaction is done. Now let's start the network. So if you see the network, we can see that there are 4 peer nodes and 1 ordering service. Because we mentioned our ordering type as solo, we are having only one ordering service. Instead, if our ordering service is, for example, Kafka, and we want to use all 5 ordering nodes, we could have seen orderer example.com, orderer 1 example, 2 example.com, orderer 3 example.com, and so on. Because this is specified as a solo in the configuration, we are seeing only one ordering node. And we mentioned in the config file that each arg will have 2 peers. So arg1, you can see here is peer 0 and peer 1. And similarly, arg2 here will see peer 0 and peer 1 being the part of the network. And finally, we have a CLI. This specific node is used to interact with because now in this example, we are using direct interaction. We're not using a SDK. If you are using an SDK, you don't need a CLI node. There you can directly use the Node SDK or Java SDK and submit the transaction to the peers. But here in this example, we are using a CLI to fire the commands directly. So the CLI. So these are all the different nodes in the network: Docker, logs, minecf. Because even now the network is started, I just want to ensure that the ordering service is ready and beginning to service requests. It is ready for any participant to submit any transaction. So to submit, create the channel, make our network formation complete, we'll first connect to the CLI. We just now till now have all the peers started and ordering nodes started but in the blockchain network, but we have not yet created any channel. So we are now about to create a channel, and this is the channel creation transaction. So what it says, I want to create a channel, and this is orderer.example.com is my ordering service, and the channel configuration transaction is specified here. Channel TX, which I said is the channel configuration transaction, which will actually create a ledger, empty ledger, with the Genesis block being the first block and so on. It will does that bookkeeping work. And what is the CA file for this? The certificate authority file. It will mention here. So you give this information and received block 0 and endorser or orderer connections initiated. So your channel is now ready. Now because channel is ready, each peer can start joining. So we will start the peer 0 or 1 here, and we will install the chain code. As I said before, the chain codes needs to be installed and instantiated. Installation is needed in order to have access to the ledger, instantiation, so that the transaction can also be executed. The specific chain code is here. We will see what this chain code or smart contract means to us. Go path. Source, GitHub, chain code, example. Okay, so this is the file. I will show you the content of the file. I'll take you through briefly what is the content of this file. So this is the content of the file. We'll briefly go over the content. So this is the installation of the chain code. And then we will see the instantiation of the chain code. So when the instantiation is happening, actually, there is one chain code container that gets created. You can see here now a new container is coming. Actually, this corresponds to the chain code container. And if you see the logs for this container, you see that the initialization of the ledger is complete, and two keys A and B are initialized with the value 100 and 200. And from where this is coming, we'll see shortly. For example, if you go a little bit up in the smart contract, this is our smart contract that I was showing you. That is a chain code example 02. So in this smart contract, there is a init function. The init function, what it does is that when we now fired this chain code instantiation, then the init function of the smart contract gets executed, and it is printing as part of executing this init function A value and B value that you can see that is coming into the log here, A value and B value, current A value and current B value. Now you can fire a query command to check what is the value of the state variable A. So I'm querying this value of the state variable, and it is showing me value 100. If you see here, it says that this query transaction got executed. Hence it says invoking query response A value is 100. So similarly, for example, if I want to check the value of B is 200, you can see in the logs invoke query command value of B is queried, which is 200 is written. Now let's do a transfer of amount from one value to the another value. So using invoke command here. So what it does is that we have two state variables A and B, and we are doing an invoke A, B, and 10. So it's doing something. The transaction is success. So if you go back to the smart contract logic here, what it says is the invoke command. What it does, whatever is the value that we are passing here as part of the invoke command, it is reducing the value from A and adding that value to B. So get state, we are getting the state of variable A, and we are getting the state of variable B, and we are reducing the value X that is done here from value A and adding value X to value B. And finally, you are writing A value and B value back to the ledger. So there is this put state and get state command, which will write to the ledger and read from the ledger. Here get state is reading from the ledger, put state is writing from to the ledger, and we are changing X value from A to B. So this is what is the invoke command here is doing. So we executed one invoke command here. So we will see what log we have got here. A value is 90 and B value is 200. So we can even now query the same value of B. Now it is showing 210. Similarly, value of A, it will show as 90. So this query transaction and invoke transaction, we have seen whatever is the transaction as per the logic that is captured, you will see that that gets executed, right? You can have any sophisticated chain code. For example, here in this first network itself, in the fabric samples, you can install any other chain code, and correspondingly you can fire the query or invoke commands. In case of example 2 here that I used just now, so this is the specific smart contract I used. So the exercise, the functions that we have exercised is the init function we exercised as part of instantiating the chain code. At that time, the values of A and B are initialized to 100 and printed. And then we have exercised the invoke command, which is a query, and the query is printing the values of whichever is the key requested by the user. It is fetching the value of that specific key and printing to the screen. So similarly, we exercised the invoke command here. So invoke command. So we got some value of X, and we are subtracting value of X from A and adding to B. So you can now exercise any number of times. For example, invoke command, I am exercising 20. I want to subtract from A to B. Now I will query value of A. It will be 70 now. So these are sample commands, query commands, and invoke commands. And this is a smart contract which you have developed. You can even write a test file, this smart contract. Before you deploy the smart contract to the channel and exercise, you should actually test the smart contract is working properly or not. For that, you can write something called Go test case if you are developing a Go smart contract, and ensure that your smart contract is properly thoroughly tested, and then you can deploy it. So maybe I will stop here. I'll wait for a few questions if you have.
Yeah, Krishna Suri, we are actually running out of time. Maybe we can take some questions, and it will be great if we can weave them through the discussion.
Sure, madam. Yeah. Sure.
Yeah. So the first question is, I tried to create a project using Composer, and he wants to convert the project into Fabric, and he's asking how he can accomplish that.
Okay, so there is a specific way to do that, but just I want to mention one point that Composer is not now deprecated from the latest version of Fabric. So due to certain challenges associated with maintaining code with Composer, that is now deprecated. So I recommend using the whatever is the latest code, Fabric code, create a network the way that I have now shown, manually configuring, or there are many different sophisticated ways also. You can access the network using SDKs. We have support for Go SDK and Node.js SDK and so on. Yeah, Composer as such is deprecated. But if you want to do that, I mean, there are certain tutorials I would probably recommend referring to that, but the highest recommendation is maybe you can use the recent code which doesn't support for this Composer, but different way of creating your network.
Yeah, thank you. So we have one more question that a participant is actually, I think she's from an educational sector, and she's asking whether she can work with Hyperledger Fabric without actually coding by using cloud or something, whether it is possible to work with Hyperledger Fabric without coding.
Without coding, yeah, of course, there are many different playgrounds offered, right? And you can actually configure these networks and use it. I can mention one thing because in specific, in a different tutorial where I was offering, right? I actually used IBM Cloud, and an IBM Cloud also actually you can have a Kubernetes cluster, K8s cluster, and all this is for free. And you can use your Gmail account, create a Kubernetes cluster, and there is a code pattern that is available out there in Google. You can search for code pattern for Hyperledger Fabric sample example. Will get that and use that, deploy the code pattern, and come to know how a Fabric network can be deployed on a Kubernetes cluster. Which all these things you are getting for free. And you can change the sample example up to whatever is your requirement. And for example, the smart contract you are changing, you want to have a different smart contract. Just now I have shown you a simple smart contract where invoke query and instantiation are done by. So you can have a different query logic, or you can have a different invoke logic. You can implement that and install that smart contract and exercise that. Yes, it is very well possible. And also Hyperledger Fabric itself has a very good documentation which can help you deploy a sample Hyperledger Fabric network on your local TP, the way that just I have now deployed, which I have done on my local TP on a Ubuntu environment locally. I created the network and exercised the network, right? So the same thing, anybody can do it. So all the steps are available in the Hyperledger Fabric documentation.
Yeah, thank you. So maybe we have some more questions, but since we are running out of time, we'll be taking it offline, and maybe you can answer that offline. Okay, so thank you so much, Krishna Narayana, for sparing your time with us. We are really delighted to have you with us, and I hope that this session was really useful to the participants. Thank you.
Sure. Yeah. Thanks, madam.
Thank you
Bye.
so much. So we are actually winding up our forenoon session now, and we'll be having our next session at 1:30 p.m. And in the afternoon session, we will be having a very interesting talk from Coding MIU from Nano Foundation, where all of you will be familiar with Nano because it's really a sustainable, green, fearless, and a fast transfer coin. And he will be talking about the adversities in open source financial networks. So see you, and we will see you at 1:30. Thank you. And the feedback form is actually shared in the chat. You can actually fill in the feedback form. And see you at 1:30. Thank you.
Hi, Colin. We'll start in 5 minutes so that more participants can join. Is that okay for you?
Yeah, it's okay. Can you hear me?
Yeah, yes.
Perfect. All right, sounds good.
We'll wait for 5 more minutes. Hi, Colin. So
Yep.
I think we should start. Participants will join on the go.
Okay.
So a little bit introduction about yourself so that participants can understand you more. So joining with us today is Colin Lemayu, the director at Nano Foundation. First of all, a huge congratulations for you and George for making Nano hits big headlines. Being instant, fearless, and sustainable, Nano makes money efficient for a more equal world, and it is the future of digital money, as it helps fight against the climate crisis and becomes ever more decentralized over time. So let me start with an introduction to Colin. He is currently the director at Nano Foundation. He has spent the past few years with leading companies like Qualcomm, Dell, AMD, and National Instruments. We are really stoked to welcome Colin and excited to hear about the adversity on open source financial networks. Over to you, Colin.
Hey, thank you. Thank you everyone for joining. Let me get my slides up. Can that be seen?
Yeah, we can see the slides.
I think so.
Thanks. Yeah.
Okay, perfect. Thank you. Yeah, again, I am the founder of the cryptocurrency Nano, and I work at the Nano Foundation. And this presentation is a little bit about our journey in open source and some of the difficulties that we've had specifically around this type of project, which is an open financial network, and some of the caveats that we've run into and some of the solutions that we have in place for it. So I'll walk through that. This is a short list of what we'll go over today. It's a little bit about Nano and the Nano Foundation, just so we have a little context on what we work on, and a little bit about the industry that we're in. And then we'll go a little bit over the concept of what our open network is and what that implies for our open software development strategy. How we take public contributions, how that's worked so far, and what we're hoping for in the future, and then a little bit about our secure development process. And then at any time, if anyone has a question, feel free to ask it. I hope there's a little bit of discussion going on, maybe some questions about how we do things or why, and that'd be great. So a little bit of background is why was Nano created? So we created it because there's a lot of problems around sending money, holding money, and in a lot of places of the world, it's not possible to do electronic banking, or it's not easily accessible. Banking restrictions, banks have very few hours, long queues, there's limited transfer allowances, high fees, and just general lack of accessibility, in addition to things like hyperinflation, money printing. Basically, at the Nano Foundation, we believe that people have the right over their own money, and if you've earned it, then you should be able to spend it as you see fit without restrictions. So what is the Nano Foundation? So the Nano Foundation is what we formed as a nonprofit foundation to work on the Nano core software, and that's the Nano node and the Nano protocol. The Nano protocol itself is an open protocol, and we developed the reference standard for that node software. And this is a little bit about our goals and what we're trying to do. We're trying to allow equal economic opportunity through allowing people to save and spend the currency that they've earned in an easier way, with low fees on an open network and a decentralized network. And I'll go a little bit over what those things mean. A little bit of background on blockchain and how we fit into that space. So blockchain is a very large encompassing term. And there's a lot of different goals, a lot of different projects out there, and I'll break down specifically what area we're looking at and the problem that we're trying to solve. So here's a list of a couple of things that blockchains are used for. This is not an entire encompassing list, but it gives you an idea of the diversity of the things that are out there. There are blockchains that work on things that are like stocks and security issuances, ICOs, IPOs, things like that, trying to do fundraising. There are blockchains that are working on logistics, trying to solve the logistics pipelines, make things more interoperable, make things effectively cheaper and easier to use. There's currency, which is the focus of what Nano is. We're focused on being a global currency. And that's the one that Bitcoin and others like that would also go under generally, is to be the currency aspect of it. And there's also identity and artificial intelligence, which are other areas that people are working on inside the blockchain space. So today we're focusing on Nano, the cryptocurrency, and the open software development process that we use. And then within currency focus, there's a few different types of what people can do to try to do a currency. So the first one that you see is probably the one that people think of the most when they think of Bitcoin and Nano. It's a free-floating currency. So there's a limited quantity or a scheduled quantity of the currency in circulation, and its value is purely determined based on supply and demand of how much people want to purchase or sell the currency at a point in time. And that's the category that we fall under. Then there's other types of cryptocurrencies, things like asset-backed stablecoins. And what those are is essentially like a bank deposit, where the value of the coins have a fixed amount in some sort of currency, usually like a government issued currency like dollars or yen or euro sterling. And your coin is tied to redemption amount. So if you have one of the coin, you can get, you know, $1 back, or whatever it is. And then the last ones are trying to do the same effect, which is to have a stable value in it. Not trying to be purely the supply and demand. And there's various projects that are trying to do that through an algorithm rather than through being backed by an asset that's possibly stored in a bank. So Nano, like I said, falls into that top category of free floating digital currency. So what is the problem that we're working on? What is it that cryptocurrency solves? So cryptocurrency solves the counterfeiting problem. It allows a piece of software to ensure that even inside of a digital system, because obviously these run on computers, even though it's digital, you can't copy or clone or produce new coins. The only ones that are out there is a limited supply, whatever's in circulation. It doesn't require law enforcement to enforce it. So usually everywhere where money's printed inside of a central bank, there's some division of the police or something that ensures that people aren't printing new notes. In addition, they also do technology inside the notes that makes them very hard to counterfeit. But what this software does that same effect in a digital format. It allows you to run it on your computer, on your mobile phone, and treat these digital quantities as money. And this is what we're mostly focused on is cryptocurrency solves the settlement problem. So anytime you send money specifically outside of your central banking system, it involves time. And your payment needs to be settled, and that time that it takes to arrive at the destination and the time it takes for them to be able to withdraw it, sometimes they're held, is the settlement problem. So Nano, as you can see in the bottom left, we focus very much on doing these transactions quickly. So Nano transactions typically settle in less than 1 second. And for comparison, Bitcoin transactions take approximately an hour, depending on how long you want to wait or the network conditions in order for your transaction to settle. So that was one of the big things that we were focusing on is improving that speed of delivery. And the last topic is decentralization. So this is our focus. What we want is this system. So we have our software and our system of money. It runs on a network. It runs on the internet. What we want to make sure is that no one group of people can control the entire network to say that transactions are valid or invalid. It also gives redundancy. This network runs 24 hours a day. So if certain computers are going down or maintenance needs to be done, the entire network needs to be resilient to that. So decentralization, there's not one entity controlling it. That is what one of our large focuses is on. And just a couple more little points on what we did and how we got here. So the Nano coins were given out for free between 2015 and 2017. There was a website that you could go on and solve a Google CAPTCHA, and depending on how many you would solve, you would get Nano periodically every hour. Our focus is definitely, as was noted in the beginning, on ensuring that we have a very low energy footprint. So Nano doesn't use mining in order to achieve its goals as other coins do. It doesn't have mining. It doesn't have that type of waste in the system. So everything inside of Nano is focused on ease of use, low resource usage, and performance on the task of being digital money. Okay, so now that we got that, now we know what Nano is. How do we interface into the open source world? So for starters, we can kind of just go over a couple of the high levels of how we do our open source development. Our code is hosted on GitHub, so all of our changes and all of our commits all go through GitHub. Yep. Is there a question? The code is written in portable C++ code. The software is non-patent encumbered, so there's no restrictions on people using similar algorithms or doing things of the like. It is a pure open source project. The license that we use is a BSD 3 clause license, which means people can use it for commercial uses. They can modify it, distribute it, use it privately. It disclaims the warranty, etc. And all of our libraries that we use, I'm very careful to make sure that we're not mixing and matching licenses, because a lot of times if you include specific licenses, they're binding to the enclosing software product. So we make sure that we have non-GPL licenses in there. Everything is a BSD3 or MIT license or other similar license, Boost license. All these type of copy permissive licenses are the ones that we use. Oh, okay, so Nano is obviously, like I said, an open source project, but more specifically than that, Nano is an open network. It's accessible by anyone in the world. Anyone can connect to it. And that brings a lot of implications around it, on it, how it's developed, how we have to do updates. A couple of things here is we can't establish a network perimeter with firewalls. Firewall certificates, permission, things like that, because that goes against our goal that was stated in the beginning, which is decentralization and being an open network. So when your software is directly interfaced with a network and you don't have a way to create a type of network perimeter, that makes a lot of the development process more difficult. Also, like what I said, this network runs 24 hours a day. So there aren't essentially maintenance windows that people can use to do upgrades or whatever. All of our upgrades have to be designed in a way that allows staggered updates on nodes across the network when people get to do it. We have a lot of different services that use Nano, and after we issue an update, we have to give a period of time for everyone to incorporate that into their maintenance window, into their maintenance process. So all of these updates have to be allowed. They have to be able to be done on the fly, and they're not all going to be done at one time, or at a time that we can even really know, because sometimes it takes some weeks to do it. So we've devised a couple ways to do these type of updates in the live and as the network's running. So the first one is probably the easiest method of doing it. So if we add a feature or add a particularly new piece to the node code, we can increase the protocol number inside of the actual network messages to indicate this node is upgraded to this version, and then you'll know that that node is capable of new features. That only covers a certain class of upgrades, a certain class of improvements. And if we can't do it with a protocol number, the next thing we do is something called a canary block. That is a hark over to the bird, the canaries. So what that is the node is programmed, with this new version to look for a specific either transaction ID or a transaction from a specific account or to an account, depending on how it's configured. But basically it is, if we need to change a behavior across the network at a point in time, what we'll do is issue the update, tell them that the canary is available. We'll watch to see how many people have upgraded to this new version. And once there's a sufficient number of people that have upgraded on the network, we'll create this new transaction, send it out to the network, and then the network will change a behavior once it's observed that block. And that's a way to, if we can't do something like with the protocol version number, where it's a smooth transition, it needs to be a sharp transition for some reason, we'll try to use the canary blocks because those are easier to put out. And then the last one is probably our most difficult type of upgrade. And this is an account level upgrade. So this is something where we're adding new context to an account. It has a new piece of information that needs to be associated with it, or there's a new restriction or a new permission on the account. and it needs to be done on an individual per account basis. When this happens, what we need to do is put out what we call epoch blocks. And those are transactions that go into each account in order to change that behavior. So this is a much larger effort in order to do. These ones we don't like to do, but they only happen in the cases where there's very large changes that need to be done in a very specific rollout pattern. So this is something that we have to do with a network that is open and live and running 24/7. It really can't be shut down. So we have to do these type of online updates in order to upgrade things. And obviously what's associated with upgrading is backwards compatibility. Backwards compatibility is kind of a trade-off. It's a benefit in that people don't need to always be on the bleeding edge of the software version, but it's a detractor if people from the software. It's a detractor from the software development process if there needs to be a lot of backwards compatibility. If you need to support nodes that are very, very old, they don't understand new concepts, they don't understand new features. And sometimes you have to make special accommodations for these very, very old pieces of software. So that's the kind of trade-off you have to do with the backwards compatibility. In the middle there, we always try to minimize breaking changes to our RPCs and our API. So services that use Nano, they do so through the RPCs that we have. We always try to limit those changes because those are the biggest breaking changes. But as I said before, there is this backwards compatibility, this old compatibility that we need to make sure that we're accounting for. In one case is in Nano. We have currently, how we do it is we have this specific transaction format. It's a data payload, it has information, digital signatures inside of it. That's the current version of it. We used to have an older version of these blocks that we don't use anymore because we found some new improvements with the new version. However, because of the way Nano works and the fact that everything's digitally signed by people, everything is in a very specific structured format, you need to know all the data. We can't get rid of those because those transactions are part of what the ledger is, what it is today. So we still need backwards compatibility on those in those blocks. And that introduces extra code that we need to maintain. So we don't have to just process new transactions. We also have to process and understand these old transaction types. As I note on the bottom though, in general, the decisions that we've made so far is to forego a lot of backwards compatibility on the network because for a couple of reasons. One is simplicity of the software development process. With simplicity, it makes it easier to not make mistakes, not introduce new bugs. When there's a lot of code to maintain for everything, it's just a simple matter of human error or software development error. You have to minimize the amount of changes that you need to do in order to secure yourself and do things in a more secure manner. So we've generally said, we give some backwards compatibility on it, but we do tend to push people to upgrade to new versions, also for security reasons. You don't want to be running old versions of software, especially financial software, when there's new updates and improvements on things. So what's our public contribution process for Nano? How do we deal with these types of things and get input from the community? The true open source development spirit, which is anyone that uses it can contribute to the process. So one of the things is, putting out a development roadmap. What are we going to work on? What ideas do we have out there? There are pros and cons to doing these types of roadmaps, and some of these are harder, a little bit harder in our industry. So pros on this is, it reassures people that we have an active development process. We're coming up with new ideas. We're improving things all the time. People want to see that. If a company is going to adopt a piece of software to be used in their business, they want to make sure that it's maintained and active. So roadmaps can do that. It can also entice people to give public contributions to these new features. So if you lay out, we want to do this, this, and this, somebody can come by that's wants to contribute to the development, pick out a specific thing or clean up a specific area. That type of thing are benefits of roadmaps. There are some drawbacks to projecting these things out too far. Anyone that's worked in the cryptocurrency space or is aware of it knows that it's a very highly competitive market. And if you project your ideas out too quickly, talk about them too soon, you lose a bit of competitive advantage. It is open source software. It is openly licensed. People can copy and put it into their systems. So you lose a little bit of competitive advantage with that. So you have to work that into the equation. And then there's an unpredictable schedule a lot of the times with these types of things. So what tends to happen is if you put out, we want to do this, that becomes, we say we have this idea that turns into we were going to do this, which turns into why is this not completed yet? Everyone wants it done today, tomorrow, last week. And it just doesn't really happen that way. Software takes time to work on, it takes time to design. And it's really hard to give deadlines a lot of time because there's unpredictable things that pop up. So there's a little bit of back and forth on this type of public planning, on open planning on it. We've kind of gone in the middle on this one, so we give a little bit of an indication of where we're going, but we won't go too far out because projecting too far out just becomes inaccurate. So a little bit about our experience so far with getting public contributions on it. So like I said, all of our stuff is open source. It's on GitHub. The majority of the commits into the Nano code base do come from the Nano Foundation. So they're people that we've hired generally, or people that we've contracted in. We do get an amount of public contributions, and actually that's started to increase this year, which has been really, really helpful. But it has been hard. We haven't gotten as many contributions as some of the other open source projects that are out there, something like Linux or something like LLVM or other open source projects. So where do I see the reasons why we have gotten what we have, and so forth. So cryptocurrency, I think the number one issue is that cryptocurrency is a highly saturated industry. So there are thousands and thousands of these projects all separating out. And what that tends to do is all of the skill set gets very, very thinly distributed amongst everyone. So you can't get a concentration of people into any one area because everyone is doing their own project individually. So that makes it harder to find contributors to contribute onto a project. Many contributors don't have the required skill set on it. Possibly they're a web developer, even a backend developer. Working on the Nano node itself is a very high learning curve industry. So I listed a few of the things that we have to work on. It's point-to-point networks. So you need to understand the networking stack up and down, firewalls, routing, all these type of things you need to understand because this runs on public internet infrastructure. And when you do that, you have every type of router variant out there. You have every type of weird routing occurrence in the network. You need to know that low level networking in order to really be able to write effectively. The Nano node itself has a high amount of resource utilization. So it's fairly IO intense. So you need to understand, what's the disk doing, what's the operating system doing when it's doing these writes. It's memory intensive, it's CPU intensive. All of these things add up to you need people with sufficient skill set in order to make contributions to it. Otherwise, you're going to lose your performance, and when you lose your performance, effectively, you've lost capability. So all the development needs to be keep that in mind. It's C++ code. So that's it's becoming a less and less common language to be used. It's still used in these types of industries, such as this, where it's performance intensive, or there's networking type of things. Basically, where it needs to be as fast as possible. C++ is still pretty industry standard for that. That along with C, there are some new languages that are coming out, but that's not what we are developed on. And then the last thing is, a lot of stuff in the node is related to cryptography. So we obviously don't invent our own cryptography. We use things that are off the shelf, but we do have to understand how to use them correctly and how to use them safely. So cryptography, hashes, digital signing, all that type of thing, depending on where you're looking at in the node, you need to understand how they're used. So the sum of all those things together means that contributing to the Nano software does require a sufficient skill set in order to do. But like I said, we're getting an increasing number of people that have been coming in this year to contribute, which is great. Trying to get them up to speed. And then the last part, which is probably one of the harder parts, is the secure development process. So obviously, Nano is a financial network. It's directly tied to monetary value. So it's an open network. So the Nano nodes have a very large attack surface. And the reason for that is because it is an open network. It's not permissioned. You don't have really a way to deny people access to the network. So everything that protects the node from attackers is inside the node code itself. Can't rely on external, physical barriers, firewall barriers, these type of things. So this is a list of what can go wrong. Anything and everything can go wrong, which is why we have to be very, very careful with our software development process. That also makes it harder for people to contribute because we have to be very, very rigorous. So remote crashes, if you're writing networking code, you have to make sure that your networking code is processing things correctly. If someone can figure out how to crash it, they can connect to any node on the network and crash all the nodes in the network. So that one is base level of what you have to prevent. Private key exposure, if you're dealing with keys, you have to make sure that those private keys never get exposed, either, well, it would never be intentionally, but it would be accidentally, either through a buffer overflow or your code was written correctly, to make sure that those private keys are dealt with very securely. Incorrect accounting is another thing. So at a base level, the Nano software, in order to be a cryptocurrency, is just an accounting software. It has accounts and then it has balances. But those changes, when you send or receive from someone, that accounting needs to be correct. Otherwise, you are not satisfying that anti-counterfeiting mechanism. If someone can figure out how to make new coins, your currency will be debased. One thing that we have to deal with in public code contributions is to make sure that there aren't underhanded or obfuscated code contributions, something that has a bad behavior, but it's not apparent when you're reading it what it's doing. Those types of things can be exploited by people. They are frequently. So, or not frequently, but there is precedent for unintended commits to be put into code repositories that have a behavior. It's essentially a backdoor behavior, and that type of thing is even prevented. Vulnerabilities in library dependencies. We do try to limit our library dependencies that we use. We only use highly well-recognized libraries that have a long track record of being safe and secure. We know who the people are that are writing it. We don't tend to pull in third-party libraries, especially if they don't have a track record of use. It's just not something we can do. And then even inside of all that, what we have to deal with are misbehaving nodes on the network, people doing it unintentionally or intentionally. Unintentionally, maybe someone is writing a new piece of software themselves to connect to the network. They want to do it in a different language, or they're doing it for a different purpose. The nodes might not behave correctly just because it's not a finished product yet. but also people can intentionally program malicious nodes in it. So what they can do is partition formation. That's a case where they try to force the network to split itself into different parts. And when it's split apart, they'll do one of two things. It either will stop working or it will not work correctly, and it will allow the accounting part to fail. So even though it doesn't sound good, we default to that first behavior, which is to stop working if a partition is formed. But obviously, the preferable thing is to write the code in a way that even if that gives no opportunity for nodes to force these types of partitions, as we do. Black hole nodes, that's just a term that we use for nodes that appear to be behaving correctly, but they're not relaying the data that they should. The Nano network uses the type of relay and replay mechanism in order to flood data out into the network. So like when you make a new transaction, you give it to one person, they give it to two people, each of those two people give it to two people, it floods it out to the network. But a black hole node will accept it and then just keep it and then won't send it on to anyone. So that type of thing, we gotta make sure we can deal around. And the last one is more of a technical term. It's called Byzantine validators. That affects the consensus process in Nano. So consensus is this mechanism of making sure all the computers in the system agree on what they have inside of their ledger. And when you do that process incorrectly, possibly even intentionally incorrectly, that's what we call a Byzantine behavior. So we need to be aware of those. So lots of things can go wrong, but we have lots of processes that go into making sure that those things don't go wrong. So the first tool in our tool belt for this type of thing are compiler-assisted code sanitizers. So these are things that go into your compiler to make sure that to make your program check itself for correctness. So on the top of this list is one called ASAN, Address Sanitizer. This is a program that you can tell your compiler to do. It'll check for memory leaks, invalid references, uninitialized variables, all these types of things, these little memory errors that are hard to discover. You can get the compiler itself to instrument the code and find these errors for you. So what we do is we turn the sanitizer on, we run the unit tests, or turn the node on and connect it to the network, let it run, and see what the output is. And ideally, the output is nothing, but it'll print out errors if it finds it. A couple of the other sanitizers we have are thread sanitizers. So the Nano node is a highly threaded program, and with threads, you need things like mutexes and things. Semaphores, all these type of thread control data structures, and those can be used incorrectly sometimes very, very subtly, and you would almost need it, but sometimes they're more apparent. So race conditions, if you have this shared piece of data between two threads, they're supposed to each lock that data object before they access it. If one of them you forget and it doesn't lock it, this thread sanitizer will say, hey, this is shared between two threads, you didn't lock it. Take a look at it, programmer. But at the end of that is one of the really difficult ones, invalid mutex ordering. For people that have worked on these type of multi-threaded programs, this is, if you lock things out of order, it can eventually cause your program to deadlock and it just stops working. With no apparent crash, you don't really get a stack trace. It just appears to not be responding. So these are the hardest ones to find, but this thread sanitizer can actually find these type of programming errors, which is very, very helpful. So there's two more in there that we use also, but they're very similar to the top ones. But basically, running these compiler-assisted code sanitizers in our development process. So we run them individually on our machines. We run them in our continuous integration process. We turn them onto a higher / slower value when we do releases to just give extra thorough checking on it. But these things are great assists in making sure that our code development is secure. Private key exposure. So this is a case where if we're doing digital signing, we're doing digital sign of everything, we need to make sure that this key is exposed. So the data type that holds our private keys is non-copyable to start off with. So minimizing the amount of copies minimizes the amount of places that it is in your system, which makes it more secure. Destructors will securely zero out the memory when it goes out of scope. And that means when we're no longer using it, we'll, rather than just letting it sit there and ignoring it, which is usually how the computer does it because it's faster, we will explicitly write zeros over everything to make sure that the data is destroyed and it can't be recovered. And then one of the things that we do is actually called a key fan out or key sharding. But what that effectively is when the private key is not in use inside of the actual program for signing, it doesn't exist in one place. It is sharded or split apart into several hundred or several thousand pieces in different parts of memory. And it's designed in such a way that you need every single piece of that key shard in order to recover it. And this gives us a little, this is a security through layers type of thing. This helps in cases where there's possibly like buffer overflows or memory scrapers that are going in there. We need to make sure that it's exceptionally hard to get private keys out of the memory, even if you can inspect memory. So that starting out, inspecting the memory is a very high bar. You have a very big problem already if someone cannot directly access the memory in your system. But this is, again, security through layers. If that were to happen, possibly through a buffer overflow will generally only dump a very small portion of memory. And by holding the keys sharded in different spots all over, we can ensure that even if that was the case, they still can't recover the key because they don't have all the parts. And then algorithm choosing is another thing that we do. Our signing algorithm has some special little features that make it immune to certain types of analysis and attacks, specifically timing analysis on key signing. So going back to the code itself, how do we make sure that every time we put in code into our repository, like how do we make sure that it works correctly? It properly does its job, it does what is intended, it doesn't have those underhanded obfuscated code commits into it. It works correctly, it passes our sanitizers. So these are a couple things that we do on this. We have a mandatory code review on each commit. So there's no one person that can just be a cowboy and put in their code commit without anyone else looking at it. As a discipline, what we say is all functional code changes must have associated unit tests that exercise all the code paths. This is something that it's a good idea on paper, and in academia it sounds very, very good. It is very hard to do in practice. I've worked at a lot of different organizations, and having good unit test coverage is not always there. So we really have had a lot of focus on doing this, and we follow this discipline pretty well. There's other benefits to doing this also. It makes your code very modular. So we stick with that. Our continuous integration process. So we commit things to GitHub, and it compiles it and runs it, but we compile it on multiple different operating systems. Right now, we just do the big three, which is OS X, Linux, and Windows, but we might expand it out to other things. The advantage of doing it on multiple systems is each of these compilers is slightly different. All of these standard libraries do slightly different things. And even when they are standardized according to the specifications sometimes leave openness as to how things are done. And when you compile it on multiple platforms, you kind of shake out all those little issues. So that's an advantage there. Our unit test coverage is actually, I think, pretty good. It's about 80% coverage on it currently. We run another compiler-assisted tool to analyze how many of the code paths get executed in our unit tests, and it comes out to about 80%. Ideally, we want that higher, probably around 90 or 95%. It is really hard to get those last 5% because they're very exceptional cases. But 80% is a good starting point. I've seen other software stacks go with like 30 or 40% coverage. So doing pretty good. And then we also, whenever we build things and push it out to people, obviously we sign the commits and hash the things that we're putting out so they know it came from us. And for anyone that wants to try out Nano, you can do that here. This is where I'll give the slides out a little bit, but nano.org is what our website is. And yeah, I'll take any questions if anyone has anything on this.
Yeah, participants, feel free to unmute your microphones and ask your queries to Colin, or you can put it in the chat box. Yeah, Colin, we've got an interesting question. Yeah, why does Nano, why is not Nano providing any airdrops? Is it because it believes in organically forming communities? Why is it so?
Yeah, so the reason we chose to not do airdrops, and instead what we did is the faucet, is because airdrops would essentially, they would be picked by me, and there's no real way. It's a little bit unfair, if I'm picking who's going to get different coins or whatever. So what we wanted was an open process that anyone can get, go onto the website, solve some of the CAPTCHAs, put in their address, and then they would get some coins out from Nano. But also we can't continue running that forever. So we did shut the faucet down in 2017. We intended to run that faucet as long as we could, as long as we can maintain it. But as the coins get more monetary value, there's a higher incentive to game the system or cheat the system. It gets incredibly sophisticated. We actually got to a point with our Google CAPTCHAs where we were consuming an extraordinarily large amount of Google's CAPTCHA traffic. I think it might have been around 10% of the global Google CAPTCHA traffic. So it quickly became infeasible to continue maintaining it. So we just simply stopped issuing new coins and burnt what was remaining.
Yeah, we've got another question. How can we resist unwanted data growth in the network?
Unwanted data growth?
Yeah.
Yeah, so that is, how do we throttle the network and how do we limit it? So that is a good question. Since it is an open network, we can't simply turn someone off if they're issuing too many transactions. So what we have is a combination of bandwidth limits and limited amount of buffering for transactions that are not committed. So when you create a new transactions, it's initially considered uncommitted or unconfirmed. As it goes through the consensus process of the network, it becomes confirmed and then it's permanently put into ledger. So since the nodes on the network need to communicate with each other in order to do this consensus process, we can limit the data rate growth by limiting the amount of bandwidth that each node uses. So that when we do that, we could say how many transactions per second do we really need at this moment? How many are coming organically versus how many are synthetically produced by people trying to attack the network? Make a bandwidth limit that fits that window, and then transactions get prioritized within there and committed. So that's our method to do it. We've actually came up with a new design for this algorithm earlier this spring, and we're continuing to implement it in our node. It's an ongoing process, but we wanted to do that and do it in a fee-less way, and in a way that doesn't require fees in the network. Good question.
Yeah, we've got one more question. What happens when the biggest voting power would broadcast contradictory votes to different parts of the network, or would not broadcast a vote at all?
Yeah, so that goes into the category of Byzantine validators. So that contradictory vote thing is accommodated for in the consensus process. So there's consensus. If you could just kind of intuitively think about a voting process, if you have greater than 50%, you win the vote. But then what this question is what happens if you give two people two different votes from you, and how are those counted? So it is involved in the consensus process. So our voting process takes that into account, but there are limits to what consensus processes can do in order to deal with that. So in things like Bitcoin and in proof of work mining, it's called a 51% attack. So you need about 50% of the validating power in order to do that type of thing. For message-based systems, it has resiliency up to 1/3. So up to 1/3 of the validators in the network can be have this Byzantine behavior, and the algorithm will still work correctly. And more fundamentally, what we do is we look at what is the cost to do this, because percentages, 50% of this, 33% of that. What does that mean? Really, what it means is how much does it cost in order to attack? So with Nano, you need to have voting weight. So you need to have coins that are, either you bought them or they're delegated to you for voting purposes, and you need 1/3 essentially of the Nano market cap delegated to you in order to get to a point where the consensus algorithm would no longer function.
Thank you, Colin.
Yeah. Any other questions? Nope.
If any other questions, then the audience can unmute and ask. If anybody want to interact with Colin.
No. All right.
Okay, thank you, Colin. And it was really an amazing session. It was very informative. And we are really fortunate to have you here. Thank you. Thank you so much.
Yeah, no problem. Yeah, thanks for inviting me. And hope everyone has a good conference.
Thanks, Colin.
Bye-bye.
Bye. Saptag, I hope you're in.
Yep, I'm here.
Yeah, I think your video is off. Can you just test the screen sharing? Saptag, can you try sharing the screen?
Yeah, just give me 2 minutes. I'll do that.
Yeah, sure.
Can you see my screen?
Yes, Saptak, we can see your screen, but we can't see you. I think your video is off.
Yeah, I am unable to choose my other camera. So I'm trying to see what's happening there.
Yeah.
I'll just reload once and see if that works.
Yeah, sure.
You should be able to see me now.
Yes, Saptak. Yeah. So are we good to start? We'll just give an intro.
Yeah, sure. Yeah.
Yeah. Sania, Miss, please.
Saptak Sengupta is a full-stack web developer and an open-source contributor. By profession, he is a techie, but he uplifts human values and he incorporates it in his profession. So he is a human rights-centered web developer. He cares more about data privacy and inclusivity. He is currently working as a contractor with Freedom of the Press Foundation. He have previously worked with other open source organizations and projects like Fossasia, jQuery, SecureDraw, Wagtail, and WebBlade, etc. He is having more than 5 years of experience in web development. He is an alma mater of IIIT Allahabad. Today, he is joining with us to give a session on making fast, accessible website using static site generators. Over to you, Saptak.
Hey, yeah, thanks for that introduction. Hello, everyone. I guess there's still 1 minute left, but I think everyone is already here, so I'm just going to start. I hope everyone can hear me clear. Let me know if.
Yes, Saptak, we can hear you perfectly.
Awesome, that's great. Okay, yeah, so today I'm going to talk, or rather take a small workshop session about how to make fast accessible websites using static site generators. Most of the session is going, I will do some coding, but most of the coding is related to the logic development rather than particularly that using that particular static site generator. So I'll try to talk more about how we think about it when we are making the websites rather than this particular code, which I think is more important. Just to start, I'll start with some warnings in case you had some other ideas from this talk. This is not a blockchain, hyperledger, machine learning, AI, or any other fancy things that people talk about kind of talk. This doesn't involve any fancy web framework, so we won't be using anything very trendy that you might be able to show off. And after today's session, some people might not consider you a programmer because still many people don't consider HTML and CSS writing as programming languages. So yeah, if any of this worries you, I'm sorry about that. But if you're still okay with that, then stick with me. And I'm pretty sure you will learn to make some fast, accessible websites today. Okay. So who am I? I think that was mostly covered in my introduction, but I'll still kind of reiterate a few of the important points. I am a human rights-centered web developer, which means I care more about privacy, inclusivity, and ethics and things like that rather than using fancy things. I maintain and contribute different open source projects and communities. So I have been working in different projects, like as both part of my freelancing work as well as just my side project. So I have been part of all the projects that were already mentioned, and I'm also maintaining many different projects like accessibilityproject.com and OnionShare and a few others. Yeah, and I do teach and make software and websites focused on privacy, security, and inclusivity mostly. I feel there's a gap. Most web developers don't really care about these things, and many people who do care about these things are not that great of web developers. So I always try to kind of bridge that gap. So that's kind of my purpose. So yeah, that's more or less about me. It's my Twitter handle. Feel free to follow me or ask any questions after the workshop if you have. Okay, so we are going to start with the very, very basic. By the way, I don't know, like, can everyone actually message in the chat, right? So in the format of a quick show of hand, how many of you have made a website of any form? Can you maybe do an yes or no in the chat? Is that possible?
Yes, sure. Participants can chat. Yes, they can.
Okay. Awesome, great. So at least like I see 3 people who have done some form of website works. I am pretty sure everyone else has at least used websites because everything today is almost a website. Now, when you make websites, a very important thing is what are the requirements for a good website? And I have made this slide at the very beginning, and after the slides, we will go into the coding part, but I feel like establishing these points is very, very, very important as a lot of you are probably still in college, and while you go out of college and start doing work, I would like you to keep all these things in mind because technologies will always evolve, but these requirements for a website almost always will stay the same. So what are the requirements for a website? Like what makes a good website? First, most of the time, the focus should be on the content of the website. If your website, unless it's a web application, which really, really needs you to have some fancy controls and things like that, totally fine. But apart from that, till now, 90% of the websites, and in fact, the World Wide Web started as a way of sharing content. So still the purpose of websites in most of the cases, even if there are other underlying technologies, would be content. So if your website is too fancy, but then it doesn't convey the content that the website is supposed to convey, that's doesn't solve the purpose of the website. So focus on content of the website is very, very important. We should always keep in mind how to show the content better. Second, resilient to high traffic. I think that is like, yep, I won't get into, and I also don't like getting into all those time complexity and speed complexity and all those kind of things. But at the same time, and most of the websites that maybe you're starting today won't get high traffics, but at the same time, it should be resilient to high traffic because after COVID-19, we are all in this pandemic situation locked in our homes. So we have seen that most websites which never thought will get a lot of traffic are actually now getting a lot of traffic. So your website should be ready for that. And it's, as we will see, it's not something that you need to do as a special thing. If you are making it in the correct way, your website by default should be resilient to high traffic. Third and very, very important point is the website should be accessible for everyone. And what do I mean by accessible is there are few different things actually. Firstly is the website should be working with the accessibility standards. So if you don't know, there are some WCAG standards which tell you what are the exact things that should be there in your website so that it's accessible. When I say accessible, it means that unlike many of us, there are many others who don't use a keyboard and a mouse to access a website. There can be different other input and output devices that they will be using. And a website should work in any input and output device, irrespective of what the user chooses it to be. So it should be accessible so that anyone with disability who chooses to use some other form of devices are also able to navigate and get the content of the website. Again, content is very important. Secondly, I feel being in India, another very important thing about accessibility is different internet speeds. In many of the Western countries, the internet is pretty good. In India, also in the cities, the internet is pretty good. But there are many remote places where we still have maybe very bad 3G or sometimes even 2G connections. So it should not take a huge amount of time to load a website just to see a content only because you chose to write some fancy JavaScripts. So it should be accessible to everyone if you are making the website, and not to the people with only the best kind of internet and technology. So that's also a way of accessibility, right? The fourth point is it should be responsive on all devices. And I think anyone who has made websites in the past few years have been conscious about this, because though maybe before it was like you only use websites on your laptop and desktop, but I'm pretty sure nowadays a lot of people actually use it on phones. So your website should be responsive over all devices, whether it be laptop, whether it be a desktop, whether it be 2K monitor, 4K monitor, or whether it be an iPhone or an Android phone or anything like that. So responsiveness is very important. And also it should be platform independent. What do I mean by platform independent? I'll get to it a little bit later, but okay, an airplane is going by. Sorry about that noise. But what I mean by platform independent is your website shouldn't be built using certain platforms on the internet, such that if that platform goes down, then your website just stops working. Or so, yeah, in a way, it's better to have platform independence so that you have most of the website written by scratch and you don't depend on other services to stay up, so that your website is also up. So that is very important as requirements for a website. Any questions till now? Awesome, I'll take the silence as a no. Now I'll talk a little bit about why I am again and again focusing on not using complex frameworks and things like that. There are certain issues. I'm not just saying because I hate them or anything like that. There are obviously use cases and applications where you would need to use those complex frameworks, otherwise they wouldn't be existing. But for most of the websites that you will build related to the contents, you don't need them because of this few, at least these 3 points. Firstly is the focus on the content of the website. So most of the times what happens is when you have a fancy UX, there are a lot of animations, a lot of interactions, which kind of gives the content to the user at a, like, not as instantaneously as they would want it to be. So it's like the first time they see it, they might be like, wow, that's fancy. But the next 2-3 times when they try that out, they will start getting irritated because they're like, okay, I just want the content. I don't care about all these things. So if it's like a content-based website, basically like if you have made a product and you make a landing page, or like a conference website or your portfolio website, or a blog, or where you write article, news websites, things like this, they don't really need to have a complex framework with a lot of interactions. So there can be a need for fancy UX if your website is an application that allows you, let's say, to draw something or edit a video. Okay, yeah, you would need fancy UX. But if it's just showing contents, then no, you don't need that. And people are just coming to your website to see the content in the most accessible way. So it doesn't really make sense to put a lot of load on their browser and their internet by just putting some fancy UX. So the focus doesn't stay on the content of the website. Resilient to high traffic. Now, most of these frameworks, complex frameworks, whether it be JavaScript or something else, makes the websites heavy and very big in size. This is not something I am just assuming and saying. You can go and check any website you load, how much size that website is, using your using the dev tools that your browser provides, and you will see they are huge. Like sometimes they're in like 50, 60 MBs even. So does most websites need that? Maybe not. Like if you're just providing content, you don't need to have a JavaScript framework loading 30 MBs of JavaScripts, right? So, and what happens is when you make these websites heavy and bigger with JavaScripts, again, the thing we were talking about, if there is a lot of traffic, what happens is you will be serving these JavaScripts also from your server. That will take time, in which case it will take more time for more people to access that website, and slowly your website will start crashing. So, and another plane is going by. But so what happens is when people start making websites using these big JavaScript frameworks or any complex frameworks, unnecessarily, if you need it, do that. But unnecessarily, if you put that, what happens is now when you think like, oh, I have to make my website resilient to heavy traffic, now you start depending on infrastructure. You will be like, hey, I need like even bigger servers. I need maybe Kubernetes. I need this and that and many other things, which might not be that important when you are making just a content website. So your focus should be that if it's not needed, maybe we should not use, then it by default is resilient to high traffic, and you don't need to worry about scaling your infrastructure. So write the website in a way that your infrastructure team doesn't need to break their heads on, hey, how should I make this faster, right? And the third important point using complex frameworks is, more than often we have seen in this past few years, is they are not very accessible. They don't meet all accessibility standards, because what we will talk about more today is that we should always write semantic HTMLs, and I'll show what semantic HTML is while we are coding. But often the code that is generated using these frameworks, because most of the times you won't write the HTML from scratch, you will write different components and things like that. And when everything is put together, it's just not very accessible. The HTML is not very semantic. There is like a huge nested div, which doesn't make sense or is not needed at all. So there are many such things happens which doesn't make it accessible for all the other devices that we were talking about. So people with disabilities have a very bad time using such kind of websites. Okay. So these are the issues. And like I have said many times, there are use cases for complex frameworks, but if your website doesn't fit that use case, do not use that. Okay, now another solution that many people use, even I think the website for this conference is probably using something like a CMS, basically like WordPress, Blogger, many other things. So there are a few points which cause issue with CMS also. Firstly, and very importantly, is a lot of these points are because you don't have a lot of control that you would have if you are writing the HTML from scratch. So it's always like putting bits and pieces together into widgets and then making the website, instead of writing the HTML from the scratch how you would like to show the website. So what happens is it's often not resilient to huge traffic. This might not hold if you are hosting the CMS website from. Okay, someone's audio is on, I think, but yeah, so it might not be an issue if you are hosting the website from your own servers, but if you're just using WordPress to host your website, maybe, and if your website is receiving a lot of traffic, there can be different things. Firstly, it might not meet your plan, and then suddenly you have to pay more money. Secondly, it can be that they start DDoSing your website, which means like any other website which causes WordPress to go down makes your website go down as well. So there are many different cases where it won't be resilient to high traffic. For accessibility for everyone, it's again the similar kind of thing. Since we are not writing the HTML, we don't really have a lot of control on making the website accessible. And So often what happens is when you're just making widgets and the way the CMSs put the widgets together, it's not very accessible and they don't follow all the accessibility standards at the end. So that's not very great. And I talked about a point called platform independence. So if this is one of the things, if you're using a CMS service provider and let's say WordPress goes down for 1-2 hours or even a day, you really can't do anything because you're not an engineer probably in WordPress. So you can't do anything unless WordPress fixes their servers. So your entire website goes down because of no fault of your own. So it's becomes like it's not platform independent anymore. You are depending on the CMS to stay up all the time so that your website is also up. Okay. So these are kind of the points why we are going to do what we are going to do today, which is using a static site generator. The very principle of static site generator is resilience through simplicity. So we won't be using, like I said again and again, any complex things. We will write very simple HTML code in a very structured format. We will have some data files, and the static site generator will basically just generate a very static HTML website. And that's it. So it's basically resilience through simplicity. And it's super light. So basically it means it just has HTML code. There is nothing heavy. So you have just HTML and CSS if you want it to be that way, and maybe minimal JavaScript if you want a little bit of interactions, and that's it. So it's very light. It doesn't have any big dependencies when you deploy it. Okay. So the basic principle of static site generator is doing something like this. So, and it also helps in a way that if you have, let's say, a separate website team and a content team, so the content team does not need to really bother about learning HTML to edit all the website. What they will do is just edit things in a markdown file or an YAML file. YAML is more structured. Markdown, some of you might know. I'll show while I'm coding. So what it does is it will take all these markdown files and the YAML files and then convert them into HTML files. And then you just deploy these HTML files wherever you want them to be deployed. And you have your website. That's it. So that's the very concept. It's very simple, no hi-fi thing happening, no pressure on the browser to generate the HTML. You will be generating the HTML in your own system and then just deploying the HTML as if you wrote the HTML from scratch everywhere. Okay. So why learn static site generators? So most of the open source content-based websites, a lot of the open source projects that you will see, if there is a website, let's say the landing page, or let's say a blog, or let's say they are writing some kind of articles or instructions or even documentations, they are usually all static site generators. So they are all websites rather created by static site generators. And the good thing about static site generator is once you learn one static site generator, it's pretty easy to pick up other ones. So only difference would be the first installation that you do, which is almost always very well documented for the static site generators. So once you have done that installation step, you are done basically. Everything else, the concepts remain exactly the same. You can actually, most of the times, the keywords that we will use, things like layouts and templates and things like that, will also be same for all static site generators. So you can just, let's say today we are going to learn something called 11T, but let's say someone is using Hugo, Jekyll, or even some static site generator that you have never heard. You can just go and start contributing to that website project because the basic principle kind of remains the same. The structure kind of remains the same. It will always be trying to convert Markdown and data YAML files into HTML. So once you learn one static site generator, you can almost always contribute to any other project, which is very unlike any other frameworks. Like Probably if you learn React, you can't just go and start contributing in an Angular project. It's very difficult. Similarly, if you know Django, it might take some time at least to learn Flask or something else. But static site generator is almost like just the installation and the running steps are different. But apart from that, maximum of the steps and the concepts are very, very same. So once you learn one of the static site generators, you can pretty much contribute to any website which is written using a static site generator. And there are more and more static site generated websites being used by open source projects as to show the content at least, right? Second point is like, and today we are actually going to do this example, is helps you create your own blog. So, or also your own website. So if you have seen my website ever, both of them and my blog, both of them are actually written using static site generators. So your blog really doesn't need to have any fancy interactions. It needs to be accessible so that everyone can read it. Also, it needs to be pretty fast. And that's it. That's what all your blog needs. So you can create your blog using a static site generator. You don't need to create your blog using React or Angular or things like that, because they are more suited if there needs to be some user interaction. Your blog probably won't have any user interaction. They are there to read the blog. That's the content. So very important. And also I encourage, if anyone, like, since most of you are here, I'm guessing that you are interested in becoming open source contributors or in some way associated with open source. Blog is very, very important. I feel as an open source contributor, it's one of the main things is learning and sharing what you know, and blog is one of the ways to do that. Also, to if you create new projects or do contributions or come across new things, is always a good idea. It goes with the open source ethos to share it with rest of the world. So obviously create blogs. So yeah, with your static site generator and the example we will go today, you can probably start writing blogs from this weekend after the conference is over. And the static site generator gives full control over the HTML and CSS that you write. So you can make your HTML, like we will do, is write completely semantic HTML. Semantic HTML by default makes your website a lot more accessible, and that's what we should do. So, and also if you start by learning static site generator developed websites using HTML and CSS, your concepts are stronger. I feel a website learning should start from HTML and CSS and not from something like React, even jQuery or Angular or something like that. Start from HTML and CSS. It will help you a lot, a lot, a lot, a lot. So that's why you learn static site generators. So what are we going to do today? We are going to create a blog using 11t. So I'll write most of the codes, and anyone is free to follow me. Any questions still here? I think you can write in chat, or I don't know how you're taking questions, but
yeah, the participants can unmute, and you can also drop your questions to the chat box.
Yeah. Okay, in case anyone doesn't have any questions, I guess we can start. To start, how many of you are using Linux? You can paste in chat, something like that. And we will basically, I'm using Linux, so I'll be demoing in Linux using Node and NPM, mostly NPM, just for the installation steps. But yeah, in case you are not using, you're free to follow, and then probably I actually have a link how to download Node.js and things like that in your Windows also. So 11t we are going to use. 11t is a static site generator. There are many different like Hugo, Jekyll, and others like that. So each of the static site generators in itself are written using some programming language, right? So 11t is basically written using JavaScript. So when you write the website, so it's a little bit confusing concept. When you write the website, the final website that you will have won't have any JavaScript. 11t itself, the package itself is written in JavaScript, which is why we need npm. And I thought if you are interested in website, a lot of you might already have npm. So yeah, we just need that for installing npm, installing 11t, and then running, or rather generating the code via 11t. But the final website that you will have won't have any JavaScript. Same concept goes for, let's say, Jekyll or Hugo or things like that, which are all written in different programming languages. Some of them are written in Ruby, Go, Rust, Python. There are static site generator using almost all programming languages now. There are like hundreds of static site generators. So yeah, every time you will see the, like I said, the installation step will be different because they are themselves written in different programming languages. So they will be using that programming language's way to install. So if you are using pip, if you are using some Python-based static site generator, you would use pip. In Jekyll and all, I think it uses bundler, which is like the Ruby's thing, Jekyll middleman, things like that. So, but yeah, you don't need to learn the programming language. That part is just copy pasting from their documentation. So even writing a website using 11t, you don't need to know JavaScript. You just need to install Node and then run the commands, which is what we will do. Okay, let's start. Can you see my terminal? I'll make it a little bigger.
Yeah, we can see. Yeah.
Okay, awesome. So yeah, I'll start with a very, very basic example. We will go ahead and make basically a website, or rather a blog website. So the first example is basically how you install 11t and things like that. So what I'm going to do is probably create a folder called this.
Saptak, can you zoom in a bit?
I can. Can you see now?
Yeah, perfect.
Okay. Okay, so what I did till now is create a directory. In Linux, you create a directory using mkdir. So mkdir my first blog. Then I just cd to get inside that directory. So now I'm inside this directory, completely blank, nothing inside. What I'm going to do is I'm going to initialize npm inside it. What this does is basically it just creates a file called package.json that will have all your dependencies. In this case, your only dependency is basically 11t. So npm init -y, done. All these steps, by the way, are also documented in the 11t website. And in any case you want me to repeat a step, let me know. But yeah, I am just following the exact same steps that are shown in the website, and everything I'll do today is actually shown in the documentation for the website. And I have that link at the end of my slides. Okay, so yeah, now we have a package. So what do we need to do now? What we need to do is we will now install 11t. So the way you do that is npm install --save dev. What it will do is it will also save it as a dependency inside that package.json file that we created, so that let's say tomorrow you need to let's say someone else is also wanting to contribute to the same project. Once you have this uploaded in, let's say, Git or any Git repository, whether it be GitHub, GitLab, anything, they can just clone it, and then they can just do npm install, and it will directly install from the package.json, and they don't have to write this entire command. So that is why we do the --save dev. So I'll do this, and that will take a few seconds, and that will install 11t for me. So yeah, let's wait for that. And anyone is feel free to follow as well. it's better if you follow, then I guess you will have a blog website by the end of this session, and then you can start making blogs. So yeah, this just shows that okay, npm has installed 11t for you. And now if we actually open this folder in a in my visual code, you will see, and I will zoom in a bit. Yeah, so what you will see is, so this is what that package.json is. It just gives a name as the package, or basically my first blog. Basically, you can put it anything. You can describe what this code does, which is probably a blog website. The main file index.js, not that important actually for us. Author, you can write your name, keywords, like things like for SEO and things. License, you can choose whatever license you want. In scripts, you can, if you have tests, you can add tests and different other things. Again, not that important for this session. The only thing is we have this dev dependency, which is 11t, and with the version. So that's it. You won't probably ever need to open this package.json again, unless you want to edit this description and things like that. Okay. So let's go to the next step. Now we have 11t installed actually. So what we will do is we will create kind of an hello world example. So what I'll do is I'll put this inside an index.md. So what this does basically is at the root of this folder, you can see the folder structure here. At the node module is where the JavaScript dependencies are installed. So at the root of this folder, it now has a markdown file. So this is a markdown file, index.md, and it has this hello world. So when you put a pound in a markdown file or the hash symbol, it says a heading. So if you have one hash, it's kind of like the heading 1. If you have 2 hashes, then it's heading 2, heading 3, and similar. So what we have now is an index.md. So it's purely a content file, doesn't have any code. You just need to know how to learn Markdown, which is basically just writing content with few specific symbols. And once you have done that, what we will do is we will run this command. And this command we will actually keep running a lot today. So this is the command npx 11t minus serve. What this will do is, first, it will convert this index.md file that we just generated into an HTML file. And once it has done that, we can actually open it as a website. So we'll see that. So if I run this command, so it's seeing wrote one file. Now you are seeing that it has created this local and this UI link. So what is important for us is this local link. So what we will do is if we just copy paste this link and go to localhost colon 8080, and you should be able to see the hello world website open. So that's it. Kind of you have a website now. This is the homepage of your website. So if you now go and let's say write a lot of the things, a lot of things are written over here about my blog, and if you go and reload this, it's written like that is your website. You have website, it has content, you can deploy this website directly, and it just works. It's super fast. You click Ctrl+R, it loads instantaneously. And what it does actually when I run that command is you will see that now there is a new folder called _site. So what happens is this index.amd, this is actually converted in _site in index.html. So whenever you will go and let's say you want to create like you want to deploy the website in a server, whether it be using a GitHub pages, or you have your own server, or you have an infrastructure team completely whom you want to give. All you need to do is just give them the content of this _site folder. Done. Yeah, and the website will be launched. That's it. As simple as that. Everything is under your control. So that's the very, very basic example. So that's the very basic example of how you would make a website. Okay. So those are basically the steps of installation of how you install 11t, and then how you serve a website. So it took us what, like 5 minutes to make a website. Done. Now what you need to know, and we will get a little bit into it, but it's again an entire thing of how to make websites using HTML, CSS. But the static site generator concept is as simple as that. There are few other concepts we are going to discuss, but it's as simple as that. You give it a markdown, it converts it into an HTML, you open it, done. So very simple, very straightforward, very fast. Now what we will do is we will get in a little bit more, right? So what we are trying to make is probably, let's say, a blog website. So what will your blog have? Your blog will have blog posts. That's probably the reason you're making a blog. So what you will do is, I created a folder called posts. Now inside this folder, what I'll do is, let's say blog1.md. So again, you're seeing all the time I'm creating a markdown file. So blog1.md, another markdown file. Now here what we will do is we will do something a little bit interesting. So we have something in almost all static site generator called front matter. Okay. It's basically something you put inside these 3 dash lines. This front matter is kind of, you can think of the metadata about this page that you will put. Again, all the static site generators will have a specific documentation about front matter. What are the default front matters that they have? What are the additional front matters you can add, and things like that. So what you will do here is kind of like adding things like the title of the website, like what is the heading of the website, the title of the website. So let's say the title of the website is my first blog. You can also add things like date over here, like the date you are publishing the blog, the author, and we will see a few other things that you can do. So what we will do is, now that we have that, let's say we write this is the first blog I ever wrote. Okay, now what we have again is, if we go ahead and run this command, same command, npx 11t @11t/11t --serve, it will again create this md into a file. So if you now open _site, you will see there is a posts folder inside which there is a blog1 folder, inside which there is index.html. So what it basically does is, now you can go to the website and open, let's say, posts/blog1, and you have your first blog. So as simple as that again. So every time you want to create a post, what you are going to do, you are going to create a new markdown file inside your posts folder. So not this post folder, sorry, this posts folder. This is again at the very root. I can show you the structure. Do I have G? That's a lot. Let's just show here. So we, at the very root of my first blog, there is a posts folder, and inside that post folders, you will just create markdowns. So blog1.md, we have one blog. If you want to create another blog, just do new file. Let's say blog2.md, and I'm just writing blog1, blog2. You can write anything. This is basically the slug, or how you would say, like in the URL. It's a little small maybe, but how the website now looks is your website domain /posts/blog1. If you name the file something different using hyphenated, that will be used as the URL path. So you can name these files whatever the URL path you basically want. And So let's say you have blog 2 now. I'll just copy because I'm lazy. And I have right. So if we have like, let's say blog 1, blog 2, and then I made 2 blogs. So now blog 1 still loads. Oh, sorry, I stopped that. So I'll just go and start the serve again. And okay, yeah. So blog 1, we have this. If I go blog 2, this has a new blog. This is the second blog I ever wrote. This has more content, blah, blah, blah. Right. So you already have 2 blogs written, like, and in posts. So again, that's how you would structure the website. Very, very simple. You exactly make folders and markdown files the way you would want the link to look like. So that's the entire thing. Index.md, whenever you write index.md, it will get converted to index.html. So that is why that's the home page. And then anything you put inside posts with whatever name, you just get the link exactly like that. So yeah, so we now have 2 posts. Now let's do what? Let's do layouts. So another very important thing, or rather a very interesting thing where we will write. So right now you are like, okay, we are writing just markdowns and they're generating HTML, but you said we can write HTML and CSS and we have full control. How do we do that? So what we are going to do is we are going to add layouts. What are layouts? So it's called different names, sometimes in different static site generator, but the idea is same. It's like templates, layouts, partials, things like that. So what we will say right now is, what happens is it just converts whatever markdowns equivalent to the HTML is. But what we can do is we can ask it that, hey, don't do that. Use this particular layout to make the website. Now, what do I mean by that? Let's make it, and I think it will get a little bit more clearer. So what we will do is we will actually add, okay, not here. We will actually add another folder called underscore includes at the root of the project. So this is an 11t default that anything that stays inside underscore includes can be used as a layout. You can change that. All the static site generators have configuration file, which also we will get into. But for the time, or most of the time, just remember to write this inside underscore includes. Okay. And that should work. Let's see. So yeah, underscore includes. Inside underscore includes, we will create a layout file. So we will create, let's say, posts.njk. njk is a called nunchucks. So there are actually different kind of templating formats. If you have used something like Django or Flask, you will know that their Flask templating engine is called Jinja. Then in Jekyll, I think it's called Liquid, or I don't know if Jekyll or Hugo. I think Jekyll. So yeah, different static site generators often have different kind of templating languages, but almost all of them are exactly same. So you don't really need to worry. Another good thing about 11t is 11t almost supports all the languages, all the templating languages, whether it be Nunchucks, Jekyll, like Nunchucks, Liquid. I can't remember any other name right now, but yeah, any other templating language you can write. They look and code exactly same. And we will see how that looks like. So what we are going to do is, okay. So before we create posts, we will actually create another file called base.njk. And why we do that, I'll get in a bit, is, so firstly, we will add the very basic HTML structure. Let's make this big. So this is how an HTML structure would look. I use this. So VS Code has this snippet thing. So I use this snippet all the time. this is how your HTML based structure should look. You should mention doc type HTML, which mentions which version of HTML document this is. HTML, this means just HTML5. It can mean HTML4 and things like that you can mention. You can also mention XML and other things. Then you have the HTML tag. The lang attribute is very important so that any device that is showing the website knows what language this particular HTML is written in. It's usually always guesses it to be English by default, but it's still important to mention in case some device doesn't. Then we primarily have a head, and then we have a body. A lot of you might already know this. So head has this title, which is shown. So when you will go to a website, you will see at the top, there are certain things remain written. Those are called the title. And it also has some meta tags. You can have many other meta tags related to your search engine optimization. Again, another very different topic in website. These are kind of the very basic meta tags that you need. One is the character set, again, to mention what character set this HTML page has. So if you mention UTF-8, it will recognize and render the UTF-8 properly, as long as your computer and browser has the capability to do that. And this meta tag basically says that use the width of the screen in which the website is shown as the device width, and initial scale is kind of the zoom to 1. Why this is important? This is very important to make your website responsive. Otherwise, what happens if you don't have this tag? The website actually won't recognize whether it's opening in a laptop or in a phone. And in the phone, it will show exactly the same as it would show in a laptop. And your website will be very small and very scaled down and horizontal in a weird way in your phone. So it won't look good. Even if you add all your CSS magic to make it responsive, unless you have this meta tag, it won't actually work. So very, very important tag. Then you have body. In body, you basically put all the contents. So whatever is shown in the website, right? So what we will do in the body, and another thing, and I'm going to talk in a bit, is why did I create two files? One is base.njk and posts.njk. This is very important and interesting. So why we're using static site generator and not just writing HTML and filling up the contents ourselves? One is, like I said, to differentiate the content workflow and the website workflow, so that every time you need to add a blog or a content team needs to add a blog, they don't need to learn HTML to do that. They can just go and create a markdown file, and the HTML is handled separately. Another very good thing about using static site generator is it follows a very dry concept. Dry meaning do not repeat yourself. So what I'll do is, if you had to write all the HTML, like everything from just HTML scratch files, you would have to write this entire structure for all the layout files that you define. But what static site generator allows is it allows some form of object-oriented inheritance concepts. So if you declare a base website and you write something like this, so this is basically the templating engine syntax. So you just put some curly braces. It allows you to write a bit of logic inside your HTML. So you can have if, for loop, like things like that inside your HTML to generate things. Again, the dry concept. So if you have a list of things that you are wanting to say generate from a data file in an YAML, you will just write a for loop and then you will do that. So this line basically just says anything that uses this layout does put whatever is there inside this body tag, or rather in this particular position. So and the good thing about 11T is anything can use a layout. So what we will do now is in posts, we will also create a front matter. And here we will say layout as base.njk. And now if we say here, let's say, what should I say? Okay, let's say we have a header tag, and then inside that in H1 we say title. Okay, and then inside main. So this is what I mean when you write a semantic HTML. So this I am writing, these are actually all HTML elements. So it's a lot of people when they write websites, they just write the entire website using just div tags. The thing to remember about div tags is div is not a semantic HTML element, which means it doesn't have any semantic properties. An HTML tag has certain properties. So it has a property like role, it has properties like how should it display, and these are very useful when someone is using an assistive technology who has disabilities. So when they go to the, like, let's say they're using a voiceover app, and when that voiceover app reads the website, when they read header, they know it's a header tag. So they will say role header, and then they will say heading 1, then they will say the title. And I made a typo here, I just noticed. So that is kind of important, because otherwise if you just write div tag and then you just style that, it won't say whether it's a heading. So the user experience that someone using a different device is getting is very different. Someone who can see the website, they can see that it's a heading, but someone who is hearing it, let's say through a voice over application, they don't know it's a heading. And it's important that they also know it's a heading. That's what makes a website accessible. That is why you should use semantic HTML as much as you can. And then, like, as a last resort, if you can't find anything else which suits your need, then use a div tag. So yeah, these are all HTML elements, by the way. It's not like I'm making up things. There are HTML elements, very important. So everything that's a heading, like your navigation, the header, like the title of the website or anything like that, you should put inside a header tag. And everything, or the content, the main content of the website should always be inside the main tag. And then if you have a footer at the end, you can actually put a footer tag also, something like this. Okay, let's say maybe something like this. Whatever you want to put in your footer. So this is how usually your website should be structured. Very, very, very important semantics. Okay, these are also used. Certain browsers and applications allow people to skip to the main area so that they don't need to care about the header and all those things. That is also only if your website has a main tag, they will know where to skip to. So again, main tag, very important. Now, whenever you are writing a blog, since we are writing a blog, there is a very handy HTML tag called article. And when you have the article, again, the voiceover and things like that recognize that this is an article. So what they're going to start reading is article. It helps them separate the article content from the rest of the website. So again, semantic HTML, very important. I could have used a div here, but I shouldn't. I should use article. Okay, and then let's say we use content save. So what this content save will do, I'm going to tell a little bit later, but what you will see is in posts.ngk, we have used this base.ngk as the layout. And in base.ngk, we said content save. So when we generate the website, like when we will do that serve command, what it will do is it will put everything here, like this entire thing in this area. So in posts.ngk, I don't need to write this entire doc type, HTML, meta tag, etc. again. I can write that entire structure in my base structure. And then I can just technically, like the footer also, let's say, probably the footer will stay the same everywhere, right? So I can put the footer just here. Yeah. And So what it will do is this entire thing, the header and the main thing, it will just put where I have written content underscore safe. So the content slash safe is replaced by whatever the content is, which is using the layout. So here again, I have written content safe, right? So why have I written this? Because now I'm going to use this layout in this block file. So front matter again, and I go write layout posts.njk. Here also I write layout posts.njk. Okay. So once I have done that, basically what it will do is this content, that this whatever I have written, and this, mind you, is again marked down. So I can have a heading level 3. This is a separate section. So I can write whatever content. You can write a full blog, and that's completely okay. And what it will do is this entire content, like it was rendering before, it will now render as an HTML, and it will put that HTML inside this area. And this HTML doesn't apply anything weird. It just converts that. It knows, okay, when you have 3 hashes, it will be an H3. So it will just do that. Everything else it will put in a paragraph. So pretty semantic as well. So it will just put it here. So let's see that. Now, if I do serve again, and what you will see, let's see first the code that it generated. So if I go in underscore site post blog 1, you will see this is the HTML that it generated right now, right? So what it has, you will see is, okay, there is an HTML tag, then we have head, the body starts here. The indentation gets a little weird, but again, you can decide to just put a tab over here, and then that would fix the indentation. You can put as many tabs as you think would actually make sense. But anyways, yeah, so that entire thing got, this header to main thing got put inside that base structure, right? And inside the article, like we have inside the article content safe. So inside the article, this rendered markdown file got put. So if I go to block 2, you will see there is a paragraph, then a heading level 3, then a paragraph that gets put inside the article. Now let's see how that looks in the website. If I reload, this is now how it looks in the website, right? So this is inside the header. I have a heading 1. Actually, every website, according to the accessibility standard, should have a heading 1 which describes what the HTML is. So very important. Heading 1, then I have the entire content that I wrote, and then the footer. So that now is a complete written blog website, and you have your blog written down. So once you have this, like let's say in this weekend you want to write a full blog, just create another markdown file inside this posts folder, write your entire blog. You can use like a markdown reference to write your entire blog. Just write your entire blog and done. That works. Like, you don't need to worry at all. You just need to do that entire blog, and then you need to do serve. Another very important, or rather interesting thing is, if you, let's say, don't write serve, you can actually just do this command. What it will do is it will just generate the website in underscore site, but it won't serve. So you can load the website now, but it will generate the latest thing inside underscore site. So if you, the last time before deploying, you kind of just run this command once and then you pass it over. But yeah, serve is good because it allows us to see how the website is. So yeah, that's kind of the very, very, very basic idea. You have layouts. You will have a layout kind of thing in almost all templating engines, or rather all static site generators using some templating engines. You should write the layouts exactly using the same concept. You have a base file, you use that base file to write other templates. And then you can have, like, let's say, like we have a posts file down. You can use the posts file, let's say, for a blog, or you can use the posts file for something else. So you will again inherit the posts file and then add some other different thing that you maybe want to add. So you just use that inheritance concept and you create template files, right? And the third important thing is once you have created the templates, you can just about create a markdown file, and then that's it. Your blog is ready. You just need to worry about writing a markdown. You don't need to worry about creating another HTML file. You don't need to worry anything like that. You just need to worry about writing a markdown file. Done, solved. That's it. And as you can see, the website, even though it's loading from my local, so it's fast, like, but it's super fast. It's 1 millisecond fast. So even if you load it using a decent enough server or even GH pages, your website will load almost as fast as Google's homepage, which we kind of used to see if we still have internet. So that's a good enough speed, right? And everything, since we are writing using semantic HTML, everything is accessible. So we are controlling what the HTML looks like. So we have full control. We can follow the standards and write the HTML exactly as we want. Nothing is generated using some magic. So everything is under our control. So if now it's not accessible, it's on you. It's not on a framework or a CMS saying that they didn't do it. Okay. So that's kind of the very basic idea. And I will get into a few other things, let's say, but till now, if anyone has any questions, let me know. You can put in the chat or you can ask me directly.
Yes, Saptak, I think we've got a question. Does a static site generator provide better performance and security?
Yes. So like I was showing, and I think kind of I answered this question, is performance is what you would say, all the, like, one of the main things is the speed probably, right? And since, like, okay, I will show you this thing. So if you go to the networks tab, and I'll just zoom that a bit. So if you go to the network tabs and you just reload the website, you will see everything happens. Okay, I have few extensions here and there, but this is the main thing, and that loads in like 39 milliseconds because it's in bytes, right? So it doesn't load, and then there is, like, these are nothing. We will, if we add a CSS file, it will need to load that CSS, but that's it. It doesn't need to load any heavy JavaScript, anything. If you want a separate font, so now the performance will depend on you. If you want, let's say, to add a separate font and your font becomes very heavy, that's on you, kind of. So you now need to learn how to optimize fonts. So that's why it's also very good to learn static site generators, because you will learn all these components as well, that how to load fonts faster, what are the different techniques I can use. There are many different techniques like preloading and things like that. CSS, should I preload my CSS, how should I break down my CSS, etc., etc., right? But it's fast, yes. Like, it doesn't load an unnecessary amount of JavaScript, because since you're writing from scratch, you don't have any JavaScript right now in your code. Like, you can see these are all kind of my browser extensions, and this is like so the server that it runs, it kinds of keeps on syncing. So if I make anything change, it will just show up. So it's all those network informations. But apart from that, the only thing it loads is this document. This is the entire thing it loads, and it's in bytes. So it's super fast. Like, now, and talking about security, yes. So a good thing about security is, so yeah, CMS sometimes, like, let's say if you're using WordPress directly, it sometimes has, so in a website, we will have something called headers. So if you see this request, we have this response headers. So right now, firstly, since it's a static site generator, and this happens to me all the time. So I have a blog. Now there are many people who try to attack my blog, get into login. With WordPress, what is the issue? You actually have an admin login. And if you go to the admin login and someone finds your password by somehow and gets into the admin login, what will happen? They can now mess up your block. But static site generator doesn't have a backend. You are just loading HTMLs. So they don't, unless they break into the server. Let's say if you're using GitHub pages, probably they can't do that. Or if your infrastructure team is good enough and they have set up their server nicely, you won't have, like, no one can actually change the content. There is no login page, so there is no user input you are taking. So even though there are many other things that you should do, but things like, let's say, session hijacking, or let's say SQL injection, or even cross-site scripting and things like that, there is no chance because there is no input. So everything of this depends on some form of inputs. There are few other things that you should do to improve the security. And again, that's one of the reasons that you should learn things writing from scratch. Helpful is you should put headers. So like here you can see whenever you load a network, you will have, this is from networking class, getting a little bit into theories. So how website works: you send a request which has a header and the packet body information and things like that. It reaches the server sees the response. First they will establish a TCP connection, then they will see the request, then they will give a response with a header and the packet. The packet is what you see, header are this information. So it will be like accept range, content length, content type, things like that. In this part, and this is actually very so easy. So if you are doing again using GitHub pages, mostly they will add all the security headers for you. There are security headers. If you want to learn more about security headers, there is a very good website called securityheaders.com, literally, and you can actually go and check your like any website. Like let's say if I check my own website and you do a scan, and they will tell you the score of your website. And these are the different security headers that I have applied. So GitHub pages mostly will apply all the security headers for you, but at the same time, if you are learning hosting a website also, this is a very good opportunity, because now anyone who is learning, let's say, infrastructure, they can now learn, okay, I need to set up security headers. How do I do? What are the important security headers? So you should set up, firstly, you should have HTTPS, then you can set up all these security headers. The security headers specifically say things like, let's say, content security policy. This will say what your website can load and cannot load. Like the CSS does, you can make such that it only loads the CSS which is hosted in your website and not via some other CDN. So you can do that. The security, you can mention all these things in the content security policy. Similarly, there is an X-frame options. What this does is it tells the website whether you should allow any other people to use iframe. So you can use an iframe tag to just load your website, load another website in your website. Let's say you can prevent people from doing that, because that actually causes some clickjacking security attacks. So these are kind of in your controls. But at the same time, let's say you were writing a website in React or something like that, you would still have to add this security header. So this security headers, whether it be using something like React, Angular, anything, Bootstrap, they don't change that. This is something which is needed at a server level, and you will need to add those when you are making your website secure. But yes, it doesn't have a login. It doesn't take any inputs from the website. So basically that way it's secure. So it can't really attack anyone directly through the website. There is nothing like that in the website. So yeah, does that answer your question?
Yeah, thanks, Saptak.
Okay. Any other questions?
Any questions from the participants? Feel free to unmute yourself, or you can drop in the chat box.
Okay. Okay, in case you don't have any other questions, we will add a little bit, like though we have very little time, but since you have no questions, I'll go ahead and make a little bit beautification of things. Let's say, so we now have a blog post, and so that I can, like, you have an entire idea of what all things you need to do if you want to make a blog post website this weekend. So another thing that you usually have in a blog page is the blog listing. So you can have that directly, what should I say, directly in the, like in the home page itself. So we will do that. We will have the entire list of blogs that you have written in the home page itself. So what we will do is we will add another template. So in index.md, we will just another template, and it includes, again, we will do home.njk. Now, what should I do? I will not write the entire HTML again. Why? Because I already have page.njk. So I'll just do layout base.njk, and that will mean that everything I write here will get put inside there, right? Now what I can do is, let's say, first, again, I'll probably have, let's try to put everything inside the main for this time, maybe. So what I'll do is inside main, I'll just put save, and that will basically what it will do. It will just convert this part into HTML and put it inside my home.njk in this area. Now I want to generate the blog list. Okay, so what we do here is we will go and we will actually add another thing in the blogs. So in the blogs, so that I can list it. So there is another concept in static site generators called collections. So in 11, and you will have the documentation for collection for all static site generator. The concept is again almost always the same. So what I'll do is I'll just go there and I'll mention a tag, and this can be, doesn't mean a tag about what this blog is about, but more like that you can mention separately. But this is just like the name, let's say, of the collection or all the blogs. So I'm just going to write blogs here. Did I write blog or blogs? Blog. Okay. So if I do that, what it now allows me to do is, like I was saying, we can actually do something like a for loop. So that's what I was saying. That's something that these things allow us to do. So again, trying to use as much semantic HTML as possible, UL, unordered list. And then what I'll do is we have for loop, which is almost exactly this same syntax as most for loops for this in the list. And what I'll do is I'll have end for, right? Yeah. So I'll have an end for, and here I can basically just make a list item. So, and then I can do href. Now, like I said, there are certain default front method things that they have. So whenever you create like a post, it always gets an attribute called the URL. So we will use URL, and this may vary from static site generator to generator, what is the thing that is mentioned or some things like that. But most of the time it will be something like URL or page URL or things like that. You will write this, and then whatever you mention here, like you specifically mention, you can access via .data thing. So post.data.title. So if I had author written, then I could have access by post.data.author. If I had date, I can write post.data.date, something like that. So what we will do is we now can have this. And once we have this, let's see. So yeah, and it should have reloaded. But yeah. So now you can see once we have this, I'll just remove the copyright thing. It looks very bad in my eyes. You get the idea. Once you have this is basically now your home page. It has a list of blogs. If you click on this, you go to the blog. And then again, if you click on this, you go to the second blog. So as many blogs will be there, you can have all the lists. And like you can actually use tags if let's say you want to have different kind of blogs in your website. Like let's say you want to have just blogs, but then you also want to have, let's say, articles, or let's say you want to have I don't know, maybe you want to have something like a list of talks you have given, or list of presentations you have given, a list of projects you have done. So you can just use the tags to create different collections, and then you can list them in the exact same way. So yeah, basically now we have the list of blogs. So kind of what is remaining is probably adding a style sheet. So I'll just quickly show how you can actually add a style sheet. And with that, I'll end the session. So what I'm going to do for style sheet is, so as you know, we have to add something called a link tag. The link tag is used. One of the reasons you use is to add style sheet. There are a few other reasons you can use. So this is again the syntax. One thing to remember here is you could have just written, let's say, so what we will do is we will write /css/style.css, and then we will create that file. But why I am writing it this way is it just creates. So often one thing that you face in this thing, since it's generating, is you don't always get a proper relative path, or you don't know what the proper relative path would be. So writing a syntax like this, what this will do is it will actually create an absolute path when it finally generates, seeing where exactly the folder is. So that is why we write a syntax like this. You can write just css style.css, but better to write something like this. So what happens, the good thing about this is, if let's say now you're thinking of hosting the website, instead of let's say yourname.com/ whatever, you can host the website now in yourname.com/blog/ the entire thing, and it will generate the URL accordingly. So that's one thing. And while we do this, so what 11t does specifically is it has this file, so like markdown file. So whenever it sees a markdown file, it will convert it into an HTML and store in the site. That's what we have seen for a CSS. And we will actually, let's first create okay, not here, not here. Again, at the root, I will create a CSS. And then inside that, I'll create, what did I name it? Why do I always forget that? Styles. Okay. So we will create, let's say, style.css. So another thing about 11t is it won't copy the CSS file. So if I just do, if I just rerun this, you will see, come on. Yeah, you will see that inside underscore site, there is no CSS folder. So you have to specifically, by default, it always just copies the, it just copies Markdown and few other things and converts them into HTML and then puts it. But you have to specifically mention that, hey, I want you to copy the CSS files also. So we will do that. For that, you have to add something called the configuration file. So the configuration file is called .11t.js. And this is kind of writing, like this is actually writing JavaScript file, but like, or rather JavaScript, but you don't really need to learn JavaScript for this. You can just copy the code from the website, which is actually what I'm doing. So I'll write 11t config, and then I just say config.set template formats, and then I can mention what all files I wanted to copy. So I'll say MD, which is already there, and then CSS. So I'll do that, and then it will be like, okay, it will now copy the markdown and CSS, and that's it. So that's what we will do. And now if I reload the file, okay, and if I go to underscore site, now you'll see that it has a CSS folder in which site which there is the style.css. So there are many other different things you can add in the config. Let's say you don't want your folder, like your project, to generate the final output inside underscore site. Instead, you want to generate inside, let's say, public or distribution or some other folder name. So you can mention all these things in the configuration. Again, all static site generators will have configurations. Again, the same concept. You can go look through the documentation, which is why reading how to read documentation is also kind of important if you're wanting to contribute in an open source project. So you just do that, and configurations are almost always understanding, then copying, and then editing what you want it to be. So you don't really need to learn JavaScript, because this is not something that you will write logically from your brain. This is well defined, so you will always copy things and then edit the way you want it to be. Okay, and now let's add some CSS. Now I'll just actually just copy paste a bunch of CSS that I have already written here. And okay, so if I do that, and now, so it looks a little bit nicer. Fonts are big, so more accessible. You will see, like, yeah, the hello world, everything is big, text is big, keep as big as possible. The color contrast, so everything, if I go, and you can actually go and check whenever you have a color. So like I just applied a main body color, so you can go and check in this body color, and it will see contrast ratio 18.88. So the accessibility standard is 7, so definitely passes the contrast ratio standard there. And like everything should pass. So basically, if I go and check, let's say now the anchor tag, it has a blue. So if I click again, contrast ratio 16, passes greater than 7, so passes it. So yeah, everything contrast ratio passes. So accessibility. Now let's say someone doesn't have a mouse, or someone has some mobile disability, so they might use something like a keyboard to tap through the entire thing. So if I have mouse, I can just click things, and I'll go to the blog. Exactly, second blog, click, go. But also, if someone doesn't have mouse, so now what I'm going to do is I'm actually going to, let's see if I can browse it via just my keyboard. So what I'll do is I'll press tab, so it goes to the next thing. Very important, again, an accessibility standard is when you press tab, this is something called a focus style. So if I show you my CSS anchor link, so here is a focus style. So this is my focus style. So, and the focus style should also kind of match the accessibility standards. Most the websites by default have focus styles. So let's say if I remove all this, so it will still have focus styles, but many of the websites focus styles. Chrome, it's okay. Firefox, it's not okay most of the times, and it doesn't meet all the accessibility standards. So it's very important that you kind of mention the focus styles yourself as well, so that when someone taps through it, they can clearly know that where exactly my tab is. And if I tab here, I'm reaching my first block, I tab my second block, I want to go there, I press enter, it goes to my second block. So now it's accessible. So we can, like we see, we don't even need mouse. We can go to the entire website using just my keyboard. So yeah, so that is basically the idea. Use CSS to enhance your accessibility, make the color contrast better, makes focus styles better. And you have your website. Like, that's it. That's your blog. You can just use that blog. That's all you need. Your blog doesn't need to have any other fancy interactions apart from this. You can always make the style links and things a little different, but that's all you need. So yeah, that's all I have to say. There, I have mentioned the link, so I'll share this. Actually, you can all just see. I will share it in the chat itself. So this is the link to the slides. So yeah, the links, all the links that I kind of used. So this is the link you would use to install Node. This is your 11T link, and this is basically the this is kind of a similar kind of project using 11T that I used as a reference. So yeah, thanks. And if you have any questions, again, ask me now. You can follow me on Twitter and ask me later as well.
If anyone is having questions, you can unmute and ask.
Do we have any question from the audience? You can also put it in the chat.
I hope that everything is clear to the audience. That's why they don't have any other questions. So
yeah, probably everyone is tired.
maybe you are that much clearly you have explained everything. That's why.
I don't ever hope that, but okay.
Yeah. So, Saptak, thank you so much for sparing your time in this open source summit. On behalf of I'm really thankful to you.
Yeah, thank you for having me.
Thanks so much.
Thank you, Saptak. It was great to have you.
Thank you. Yeah.
Bye.
Bye.
So to the audience, tomorrow also, we have some sessions coming up. So tomorrow we'll start at 9:30. We have a session by Martin Barr, Building Force Communities. Then we have a session by Rushil Sharma, How to Open Source. We have a panel discussion in the afternoon, Diversity and Inclusion in Open Source, Hong Fook, Soumya, Samson Godi, Chiuk Ting Ho, and Ariel Fox. And we also have a lightning talk by Jan Ainali, Real World Collaboration through the Standard of Public Code. And we also have an interesting talk by Christy Progry, Introduction to GNOME Community. So thank you so much. We'll see you tomorrow. Bye. Take care.